Hello there and welcome to Physics with William, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we are setting off on a quiet journey into a question that feels simple at first, almost like the sort of question a child might ask while staring out of a car window at the evening sky, but the more we sit with it, the larger it becomes. Why does the universe not have a centre? It sounds as though it should. Most things around us seem to have one. A room has a middle, a table has a centre, a circle drawn on a page has a neat little point you can mark with a pencil. Even a slice of cake, if you're patient enough and not too hungry, can be divided into equal pieces around a middle. So naturally, when we think about everything there is, all the galaxies, all the stars, all the glowing clouds of gas and dust, all the dark spaces between them, we may imagine that somewhere out there, perhaps very far away, there must be a grand central point. A cosmic downtown. The place where the universe began, where everything first rushed outward, where space perhaps still carries the faint memory of some original spark. It is a tempting idea. It is also, as the universe so often enjoys doing, quietly misleading. Before we wander into expanding space, ancient starlight, distant galaxies, and the strange geometry of everything, let me ask you something gentle. Where are you listening from tonight? And when you imagine the universe around you, where do you picture yourself inside it? Do you feel as if Earth is somewhere near an edge, like a small pebble tucked away in a dark corner? Do you picture us floating somewhere in the middle, perhaps by chance, perhaps by comfort? Or do you not picture a location at all, only a great darkness scattered with lights, too large to arrange in the mind? It is a funny thing, really. We live our whole lives in places with directions. We know where the front door is. We know where the nearest shop is. We know whether the kettle is to the left of the sink or hiding behind the bread because someone put it there for reasons known only to them. Our brains are very good at mapping space on ordinary human scales. We use centres, edges, routes, distances, and landmarks. We find our way by turning the world into a kind of mental map. But the universe is not a room, and it is not a table, and it is not a cake. Even though a cake-based universe would probably have better public approval, if you find this kind of quiet cosmic wandering soothing, intriguing, or just a pleasant way to let the day loosen its grip, I would be ever so grateful if you gave the video a like and perhaps subscribed if you have not already. It helps this little corner of calm science reach other tired travellers who may also be lying there wondering whether the universe has a middle, an edge, or possibly a misplaced instruction manual. And as always, I do hope this is interesting enough to keep you company, but not so interesting that it keeps you awake. The universe has been expanding for billions of years. It can wait politely while you drift off, so settle in, let your shoulders drop, let the room around you become a little quieter, and let us begin with the picture that most of us naturally carry. When people first hear about the Big Bang, it is very easy to imagine an explosion. Not just any explosion either, but an enormous one, the greatest explosion of all, a blast of matter and energy erupting from a single point into a vast surrounding emptiness. In that picture, galaxies fly outward like sparks from a firework, and if we could somehow rewind the cosmic film, we would see them all racing back toward one original location. That location, it seems, would be the centre. Simple, tidy, and completely understandable. The only trouble is that this is not quite what cosmologists mean when they talk about the beginning of the universe. The Big Bang was not an explosion in space, it was an expansion of space. That difference may sound small at first, like a technical correction from someone who alphabetizes their spice rack, but it changes almost everything. An explosion happens at a place, it begins somewhere, and it sends material outward into space that already exists. If a firework bursts in the sky, there is a centre of that burst, and there is air around it for the sparks to travel through. If a balloon pops, pieces of rubber fly away from the place where the balloon used to be. But when we speak about the early universe, we're not talking about matter flying into pre-existing emptiness from a central point. We're talking about space itself stretching. The distances between things grew because the fabric of space was expanding everywhere. Not from one privileged spot, not away from a cosmic headquarters, but everywhere at once. Every region of space was closer to every other region in the past, and as the universe evolved, those distances increased. That is the quiet twist at the heart of tonight's journey. If every place was part of the expansion, then no single place can claim to be the center of it. This is not an easy idea to hold, because our minds want a viewpoint. We want to stand somewhere and look outward. We want a diagram with a dot in the middle and arrows pointing away from it. Scientists use diagrams like that sometimes because they are useful, but they can also sneak the wrong picture into our imagination. A drawing has an edge because the page has an edge. A circle on a screen has a middle because it is drawn from outside. But the universe is not something we can step outside of and sketch from the cosmic balcony. We are inside it. Every telescope, every measuring device, every drifting space probe, every astronomer with cold coffee and a late-night data set is also inside the thing being studied. There is no known outside vantage point from which to point and say, there it is, the middle. The universe does not present itself like an object sitting on a shelf. It is the whole stage, the actors, the scenery, the light, the dark, and the slightly confused person in the back row still wondering where they parked. One of the reasons the idea of a centre feels so natural is that for most of human history, we placed ourselves very near it. Not always through arrogance, though there was certainly a bit of that from time to time, but because the sky appeared to say so. The stars seemed to wheel around Earth each night. The sun rose, crossed the sky and set. The moon followed its own pale path. From the ground, it looked as though we were still, and everything else moved around us. Ancient models placed Earth at the centre of the cosmos because that was the most straightforward reading of the evidence available to the human eye. And honestly, from a backyard without a telescope, it is not a bad guess. If you did not know Earth was spinning, if you did not know it was orbiting the sun, if you did not know the stars were distant suns scattered through a galaxy, the heavens really would look like a grand rotating dome with us underneath it, comfortably central and perhaps just a little important. Then came the long humbling. Earth was not the centre of the universe. It orbited the sun. Then the sun was not the centre of the universe. It was one star among many in the Milky Way. Then the Milky Way was not the whole universe. It was one galaxy among hundreds of billions, perhaps more, spread across distances so large that even light needs more patience than any of us can reasonably be expected to have. Each time our instruments improved, our central seat became less central. The universe did not become less beautiful because of that. If anything, it became more astonishing. We were not sitting in the middle of a small clockwork dome. We were living on a planet around an ordinary star in one spiral galaxy, among a vast cosmic population. That can sound small, but it also means we're part of something far grander than the old picture allowed. We lost the throne, perhaps, but gained the universe. Still, even after we learned that Earth was not central, another version of the same instinct remained. Perhaps we thought, fine, Earth is not at the centre, and the sun is not at the centre, and our galaxy is not at the centre, but surely the universe itself has one somewhere. A final centre, a true origin point, a place where the cosmic expansion can be traced back to a beginning. This is where the modern answer becomes both simple and strange. As far as our best observations show, the universe looks broadly the same in every direction on the larger scales. Not exactly the same in the small details, of course. One direction may contain a nearby galaxy cluster, another may contain a great cosmic void, another may lead our telescopes through dusty regions of the Milky Way that make astronomers sigh and clean their data very carefully. But if you zoom out far enough, beyond individual galaxies and clusters, the universe appears remarkably uniform. It has no obvious central pile-up, no preferred direction, no great empty side and crowded side. It looks, in a deep statistical sense, like a universe that does not care where you stand. This is one of the great clues. If the universe had exploded from a centre into empty space, you might expect galaxies to be arranged around that centre or to move in a way that reveals it. You might expect one direction to look younger, denser, or more important. But what we see instead is that distant galaxies appear to be moving away from us in all directions. At first glance, that sounds suspiciously like we're at the centre after all. Everything is moving away from us. How convenient, how flattering, how very human of us to notice. But the same thing would be seen from any other galaxy, provided there were observers there with telescopes, patience, and perhaps a fondness for late-night snacks. From their point of view, distant galaxies would also seem to be moving away in all directions. Not because they are at the centre either, but because space itself is expanding between galaxies everywhere. A common way to picture this is to imagine dots on the surface of a balloon as the balloon inflates. Every dot moves away from every other dot, yet no dot on the surface is the centre of the expansion. The centre of the balloon is not on the surface at all, and for the creatures living only on that surface, asking for the surface centre would be misleading. This example is useful, though like all examples it has its little traps. The universe is not a balloon floating in a room. It does not need air around it, and as far as we know, it is not expanding into some larger ordinary space. The point of the balloon image is only that expansion can happen everywhere, on a space without there being a centre within that space. If that picture starts to help and then starts to confuse, do not worry. That means it is doing what most cosmological metaphors do. They carry us across the river, then wobble slightly near the opposite bank. The deeper idea is that a centre is not always required. It depends on the kind of space you're talking about. A line segment has a middle, a circle drawn on paper has a centre, a ball has a centre. But if space is all there is, and if every part of space is expanding relative to every other part, then the centre is not missing in the way a button might be missing from a shirt. It is simply not part of the description. Asking where the universe expands from is a bit like asking where the surface of Earth begins. You can choose a starting point for a map. You can call one line the prime meridian. You can draw borders, grids, and labels. But Earth itself has no natural starting point on its surface. The labels are ours. Useful, yes. Real in a practical sense, certainly, but not written into the planet with a cosmic pen. Now, because this is a sleep-friendly journey and not a lecture hall with uncomfortable chairs, we can let that idea rest gently for a moment. The universe does not have a centre, because the expansion of the universe is not motion away from one special place. It is the growth of distance throughout space. Every observer sees themselves at the middle of their observable universe, not because they occupy the true centre of everything, but because they can only see as far as light has had time to travel to them. You, right now, are at the centre of what you can observe. I am at the centre of what I can observe. A distant astronomer in a galaxy far beyond our reach would also be at the centre of their observable patch. Not the centre of all reality, but the centre of their view. In that sense, the universe gives every observer a kind of private horizon, a round window of visibility. Not a throne exactly, but perhaps a very large and mysterious porthole. This distinction between the whole universe and the observable universe is going to matter. When we look into space, we're also looking back in time, because light travels at a finite speed. The farther away something is, the older the light we receive from it. There is a limit to what we can see, not necessarily because the universe ends there, but because light from beyond that limit has not had enough time to reach us since the hot early stages of the cosmos. That boundary surrounds us in every direction, which again can make us feel central. But it surrounds us because we are the ones observing from here. Move to another galaxy, and the observable boundary moves with you. Like carrying a lantern through fog, you're always at the centre of the circle of light, but that does not mean the fog itself has chosen you as its favourite. There is something quietly comforting about this, if we let it be. We are not the centre of the universe, and neither is anyone else. There is no cosmic capital city, no privileged balcony, no single place that gets to say, everything began here and all else is outskirts. Instead, every location is woven into the same expansion. Every galaxy, every cluster, every dark stretch of intergalactic space participates in the same large story. That does not make our place meaningless. It makes it connected. We are not important because we sit at the centre. We are important because we are part of the universe becoming aware of itself from one small, temporary, astonishing viewpoint. A planet can be ordinary in location and extraordinary in what happens upon it. A listener can be nowhere near the centre of space and still be exactly at the centre of their own experience tonight, with a room around them, a breath moving in and out, and the mind slowly opening towards something larger. So as we begin, try to notice the old picture in your mind if it appears. The dark empty space, the bright explosion, the galaxies rushing away from a central point. It is a natural image. It has helped many people start thinking about cosmology. But now we can begin to loosen it. We can replace it with something subtler. Not a blast into emptiness, but space stretching everywhere. Not galaxies fleeing from a middle, but distances growing between galaxies. Not a universe with a hidden centre waiting to be found, but a universe in which every place can look central from the inside. The shift is gentle, but once it settles in, it changes the whole room of the mind. And perhaps that is where the real story begins, not with a telescope aimed at the farthest galaxy, but with the human habit of placing ourselves in the middle of the map. Long before modern cosmology, long before anyone spoke of expanding space or distant galaxies, people looked up at the turning sky and tried to understand where they stood. The stars moved with such order. The sun returned with such confidence. The seasons circled back again and again. It made sense to imagine a universe arranged around us, with Earth resting steady at the heart of creation. That ancient dream of standing at the middle was not foolish, it was human. And to understand why the universe does not have a centre, it helps to begin with the time when we were almost certain that it did. That ancient dream of standing at the middle was not foolish, it was human. It began with the simple fact that from where we live, Earth feels still. You can stand in a field or on a pavement or beside a quiet window at night, and nothing about the ground beneath your feet suggests that it is spinning. It does not feel as if you are being carried around the sun at great speed. It does not feel as if the sun itself is moving through a galaxy, and that the galaxy is drifting through a universe filled with other galaxies. It feels as if here is here, and the rest of the sky is what moves. The sun climbs and falls, the moon rises and changes shape, the stars sweep overhead in slow circles. If you had only your eyes, your patience, and a good view of the night sky, the most reasonable first guess would be that the heavens turn around us. That was the world as our ancestors saw it. Not as a small blue planet orbiting an ordinary star, but as the steady floor beneath a great turning sky. The stars appeared fixed to a dark dome. The planets wandered against that background like curious lamps that had missed a meeting. The sun and moon returned again and again with enough regularity that people could plant crops, plan ceremonies, navigate landscapes, and wonder whether someone somewhere had arranged the whole thing with admirable attention to detail. The sky was not just scenery. It was calendar, compass, clock, and storybook all at once. It told people when the rains might come, when animals might migrate, when rivers might flood, and when winter would begin to loosen its grip. In that kind of world, to stand under the sky was to stand at the centre of meaning, even before anyone claimed to stand at the centre of space. Many ancient cultures built their lives around this sense of cosmic order. Temples, tombs, stone circles, pyramids and observatories were aligned with solstices, equinoxes, and the paths of bright stars. These structures were not just impressive bits of ancient construction, though they were certainly that too. especially considering nobody had modern cranes, computer modelling, or a local hardware shop offering a weekend discount on sacred limestone. They were expressions of a deep relationship with the sky. People watched the heavens because the heavens mattered. They seemed to guide life on Earth, and because the same patterns returned year after year, it was natural to imagine a stable, ordered cosmos surrounding a stable, ordered world. In the ancient Greek tradition, this view became more formal. Thinkers tried to turn the observed movements of the sky into a system that could be reasoned about. Earth, heavy and solid, seemed to belong at the centre. Things fell downward toward it. Flames rose upward away from it. The heavens seemed smooth, circular and unchanging, while the earthly realm was messy, damp, crumbly and forever needing repairs. It made sense within that framework to place Earth at the centre, with the moon, sun, planets and stars arranged in nested paths around it. The universe became a set of spheres, elegant and orderly, turning around our world like a great celestial machine. One of the most influential versions of this picture came from Claudius Ptolemy, an astronomer and mathematician working in ancient Alexandria. His model placed Earth at the centre and used a clever system of circles upon circles to explain the movements of the planets. These extra circles were needed because the planets sometimes seemed to slow down, stop, and move backward against the stars before continuing forward again. This backward-looking motion is called retrograde motion, and it was a real puzzle. Mars, for example, does not simply glide in one smooth path across the sky. It occasionally appears to loop. To the naked eye, it is as if the planet briefly changes its mind, takes a few steps back, and then resumes its journey with the awkward confidence of someone who has just walked into the wrong room. Ptolemy's system handled this by having planets move on smaller circles, whose centres moved on larger circles around Earth. It was complicated, but it worked well enough for predicting planetary positions, and that is important. The old Earth-centred model was not merely a superstition held together by stubbornness. It was a serious attempt to explain real observations. It had mathematics. It had predictive power. It was useful. For many centuries, it gave astronomers a way to calculate where planets would appear in the sky. A model can be wrong in its deeper picture and still be useful in practice. This is one of those quiet lessons science teaches again and again, usually after making everyone do a lot of careful measuring. The Earth-centred universe also fit neatly with human experience. We naturally organise life around ourselves, not in a selfish way necessarily, but because each of us has only one point of view. The world arrives through our senses from where we happen to be. Sounds come toward us. Light enters our eyes. Distances are judged from our bodies. A village map starts from home. A child learns left and right from their own hands. Even now, when we know Earth is not the centre of the universe, we still say the sun rises and sets, because that is how it looks from here. Language preserves old viewpoints long after science has moved on, like a comfortable sweater that no longer fits the official dress code, but is still very nice on a cold evening. There was also a kind of comfort in the old picture. A central Earth suggested a universe built around human concerns. The sky was above, the ground was below, and everything had its place. This did not always mean people believed Earth was honoured by being central. In some traditions, the centre was not the throne, but the lowest point, the heavy and changeable realm beneath the perfect heavens. Still, either way, Earth had a special position. We were not lost in a vast cosmic ocean. We were located, framed, and enclosed. The universe, though large and mysterious, seemed arranged in relation to us. That can be a reassuring thought when the night is dark and the stars are many. But observation has a way of gently disturbing comfortable arrangements. The first major shift came not because someone suddenly disliked the idea of Earth being central, but because the sky became easier to explain when the sun was placed near the centre of the planetary system. Nicholas Copernicus, in the 16th century, proposed that Earth and the other planets orbit the sun. This was not simply a change in furniture, like moving the sofa from one wall to another. It was a rearrangement of reality. Earth became a moving planet, The daily motion of the sky could be explained by Earth spinning. The yearly motion of the Sun among the stars could be explained by Earth orbiting. Retrograde motion no longer required such elaborate planetary loops. Mars only appeared to move backward because Earth, on an inner orbit, was passing it, rather like a faster runner overtaking a slower one on a track. No offence to Mars, of course, it is doing its best. This sun-centered model did not instantly sweep everyone away. It had problems and early versions were not perfect. It also challenged long-standing philosophical and religious ideas, but it introduced a powerful possibility. Perhaps the feeling of being still was misleading. Perhaps the sky was not turning around us. Perhaps motion could be real even when we did not feel it. That thought alone is enormous. It tells us that common sense, while useful for chairs, doors, soup bowls, and not walking into ponds, can struggle when applied to the universe. Then came the telescope, and with it, the old cosmic walls began to crack. Galileo Galilei turned his telescope toward the sky in the early 17th century and found things that did not fit easily into the old picture. The moon was not a perfect smooth sphere. It had mountains and craters. The sun had spots. Venus showed phases, which made more sense if it orbited the sun. Jupiter had moons of its own, little points of light circling another world. That last discovery was especially important because it showed, plainly and beautifully, that not everything revolved around Earth. There were smaller centres of motion out there. The universe was becoming less like a single court with Earth as its fixed monarch, and more like a vast arrangement of systems, each with its own local order. Even then the humbling had only begun. Once Earth became one planet among several, the Sun took over as the new central anchor. It was natural enough. The planets orbit the Sun, and the Sun dominates our local system with its mass and light. For a time, one could still imagine that, although Earth was not central, the Sun might be. Perhaps the solar system sat at or near the centre of the wider universe. But as telescopes improved, the Milky Way emerged as a great band of countless stars, and eventually the Sun was understood to be one star among many, not at the centre of all things, but located in the outer regions of a galaxy. The centre had slipped away again. The Milky Way itself then became the next candidate for cosmic importance. For a while, many astronomers thought it might be the whole universe. Those faint cloudy patches in the sky, known as nebulae, were debated. Were they small objects inside our own galaxy, or were they distant star systems in their own right? This question became one of the great turning points in astronomy. In the early 20th century, observations showed that at least some of these nebulae were far beyond the Milky Way. The Andromeda Nebula, for instance, was not a nearby cloud. It was another galaxy, an enormous collection of stars like our own Milky Way, separated from us by a staggering distance. Just like that, the known universe grew again. The Milky Way was not the universe. It was one galaxy among many. It is hard to overstate how large this shift was. Imagine believing that your town is the whole world, then learning there are other towns, then countries, then continents, then planets, then a sky full of islands of stars. The scale of reality kept expanding beyond the scale of human expectation. Every time we thought we had found the outer frame, the frame moved. Earth was not central. The Sun was not central. The Milky Way was not central. And eventually even the idea of a centre itself began to look less like a hidden location and more like an old habit of thought. This habit is understandable because centres are useful on small scales. A wheel needs a hub. A spinning top has an axis. A town often has a square or market. A galaxy may have a dense central region, often with a massive black hole deep inside. A solar system has a dominant central star. These are real centres, local centres, practical centres. The trouble begins when we take an idea that works for smaller objects and stretch it across the entire universe. The universe is not simply a larger version of a solar system. It is not a giant galaxy with a bright middle and a fading edge. It is not a ball of stars expanding into a dark room. The universe includes the room, if one may call it that, and the darkness, and the distances, and the rules by which distances make sense. Still, human imagination tends to search for a middle. Perhaps it is because a centre gives a story a starting point. If there is a middle, then there is a place from which things began. If there is an edge, then there is a boundary to the unknown. A centre and an edge make the universe feel like an object. They let us picture it as something with a shape we could hold in the mind. Without them, the universe becomes harder to draw, and what we cannot draw, we often struggle to trust. This is why cosmology asks a special kind of patience from us. It asks us to think beyond the pictures that helped us understand smaller things. It asks us to accept that the universe may not be arranged around the kinds of landmarks our brains prefer. The old dream of centrality also appears in more subtle ways. Even after learning that Earth is not physically central, people sometimes imagine humanity as central in meaning. We look at the stars and ask what they're for. We look at the vastness and ask what our place is. These are not bad questions. They are natural questions, but science answers a narrower one. It asks where we are, what we observe, and what those observations imply. Meaning is something humans build, share, argue over, and sometimes misplace under a pile of laundry. Location is something we measure. The universe can be physically centerless and still be meaningful to us. In fact, perhaps the meaning becomes more interesting when it is not handed to us by geometry. The gradual removal of Earth from the center is sometimes called a humbling process. But that word can sound a little gloomy, as if science has spent the last few centuries politely taking away our favorite chair. There is another way to see it. Each step away from centrality also opened a larger view. When Earth moved from the center, we gained a solar system. When the Sun lost its special status, we gained a galaxy. When the Milky Way became one among many, we gained a universe rich beyond ordinary imagination. We did not shrink so much as the world grew. The story became bigger than the role we first assigned ourselves. There is also a useful lesson in how slowly the shift happened. People did not wake up one morning and suddenly see the universe correctly. They gathered observations, argued over models, built instruments, made mistakes, improved methods, and changed their minds when the evidence required it. This is one of the quiet strengths of science. It is not that scientists are magically free from old assumptions. They are people, and people are very good at being attached to familiar pictures, especially if those pictures come with neat diagrams and social approval. The strength lies in building methods that allow reality to push back. The sky does not care what model feels comfortable. The planets move as they move. The telescope shows what it shows. The data, if handled honestly, has a way of clearing its throat. By the time modern cosmology began to take shape, the question had changed. It was no longer simply whether Earth sat at the center. It was whether the universe as a whole had any preferred location at all. When astronomers looked outward, they found galaxies in every direction. When they measured the motions of those galaxies, they found a pattern that suggested expansion, but the pattern did not point to a single visible center. Instead, it seemed that the farther away galaxies were, the more their light was stretched in a way that matched an expanding universe. From our viewpoint, galaxies appeared to be receding all around us. The old instinct might whisper, "There it is, we are central after all." But by then, science had learned to be suspicious of flattering conclusions. If every observer in every distant galaxy would see a similar pattern, then the pattern is not telling us that we are special. It is telling us something about the structure of space itself. This is the turn from ancient centrality to modern cosmology. The sky once seemed to rotate around Earth because Earth was our observing platform. Now the distant universe seems to recede from us because any observer sees expansion from their own location. In both cases, the lesson is the same. What appears centered on us may be a feature of perspective, not proof of privilege. That is a gentle but important distinction. Perspective is not an error in the careless sense. It is the necessary starting point of all observation. You cannot look from nowhere. Every measurement is made from somewhere. The task is to understand which features belong to the universe and which belong to the viewpoint. The ancient astronomer saw stars circle the sky and concluded that Earth was central. The modern observer sees distant galaxies recede and must learn not to make the same mistake in a grander form. The universe has a way of giving every observer a view that feels central. It is not deception. It is geometry. So when we speak of the ancient dream of standing at the middle, we're speaking about more than an old astronomical model. We're speaking about a human starting point. We begin from ourselves. We map the world outward. We place home near the centre because home is where the map is used. Then evidence teaches us to widen the map, again and again, until the centre becomes less a place and more a habit we have learned to recognise. The night sky, once a dome turning around us, becomes a window into a universe where every direction is deep, every location is local, and no single point has been appointed the middle of everything. And this prepares us for the next quiet surprise. If the universe has no centre, why does it look from here as though we are surrounded on all sides by distance, depth, and ancient light? Why can every observer, wherever they are, feel as if they occupy the middle of a great cosmic sphere? The answer begins with the difference between being at the centre of everything and being at the centre of what you can see, which sounds similar enough to cause trouble, but turns out to be one of the most helpful ways to understand the centreless universe. The answer begins with a very ordinary experience. Wherever you stand, the world seems to arrange itself around you. Stand in a quiet field at dusk, and the horizon forms a circle with you at the middle. Turn slowly, and every direction stretches away from your feet. North, south, east, west, all of them seem to begin where you are. You do not conclude from this that you are the centre of Earth. At least I hope not, though it would make for a very confident walk to the shops. You understand without much effort that the horizon is centred on you because it is your horizon. Move to another field, another hill, another beach, and the circle moves with you. The world has not rearranged itself in your honour. Your view has changed. The universe does something surprisingly similar, though on a scale so large that our ordinary instincts can wobble a little. When we look out into space, we see galaxies in every direction. We see ancient light arriving from all around us. We see a vast observable region with Earth near the middle of the view. And because the view appears centred on us, it is tempting to wonder whether we have quietly returned to the old idea after all. Maybe Earth is not the centre of the solar system. Maybe the Sun is not the centre of the galaxy. Maybe the Milky Way is not the centre of all galaxies. But perhaps, somehow, in the largest picture, our location is still close to the centre of the universe. It is a very human thought. A sneaky little thought in slippers, tiptoeing back into the room after science politely showed it the door. But the key is this. We are not at the centre of the whole universe. We are at the centre of our observable universe. That one word makes all the difference. Observable. It means the region from which light has had enough time to reach us since the universe became transparent long ago. It is not a wall. It is not an edge. It is not the place where reality stops and someone forgot to paint the scenery. It is simply the limit of our cosmic sight. Just as your horizon on Earth is not the edge of Earth, the horizon of the observable universe is not necessarily the edge of the universe. It is the edge of what can be seen from here, at this moment in cosmic history with light travelling through expanding space toward our telescopes. This is why every direction can look like the centre. Every observer carries their own observable universe with them, not literally like a suitcase, though that would be quite a piece of luggage, but in the sense that the visible region is defined by where the observer is. Imagine a person standing on a plain in thick morning mist with a lantern. The light reaches only so far before the fog swallows the view. To that person, the visible world is a circle around them. Now imagine another person far away with their own lantern. They too stand at the centre of their own visible circle. Neither person is the centre of the whole plane. They are simply the centre of what they can see. The universe is like that, except the lantern is not shining outward. Instead, ancient light is arriving inward, and the fog is replaced by time, distance, and the expansion of space. When astronomers look out, they are always looking backward in time. This is one of those facts that sounds poetic but is really just patient physics. Light does not arrive instantly, it travels. The moon we see is the moon as it was a little while ago. The sun we see is the sun as it was several minutes ago. The nearby stars are seen as they were years ago. Distant galaxies are seen as they were millions or billions of years ago. Looking farther into space means looking deeper into the past. A telescope is not just a bucket for light. It is a time machine with a very clean mirror and a long waiting list for observation time. Because the universe has a finite age, there is a limit to how far back we can see. Light from beyond a certain distance has simply not reached us yet, or has been stretched and shifted in ways that make the early universe itself the boundary of what can be directly observed. This limit surrounds us in every direction. It forms a great sphere of visibility, with us at the centre, not because the universe has chosen us, but because seeing is always centred on the observer. If you were in a galaxy far away, your observable sphere would be centred on you. It would overlap partly with ours if you were not too far away, but it would also include regions we cannot see, and exclude some regions we can. Every observer has a different cosmic window. This is one of the most important distinctions in cosmology, and also one of the easiest to miss. The observable universe is not the same thing as the entire universe. The observable universe is our view, our reachable light, our portion of the whole. The entire universe may be much larger. It may be so large that our observable region is only a tiny patch. It may even be infinite, though infinity is the sort of word that walks into a conversation and immediately knocks over the furniture. We do not need to settle that tonight. The important point is that the part we can see is not necessarily the whole thing. Confusing the observable universe with the whole universe is a little like standing in your garden at night, seeing only the circle lit by your porch lamp, and concluding that the world is shaped like a small glowing patch with suspiciously many moths. Now, what do we actually see when we look in all directions? On the larger scales, we see a universe that appears remarkably even. Galaxies are not arranged perfectly smoothly, of course. The universe has structure. It has clusters of galaxies, long filaments, enormous walls, and vast empty-looking regions called voids. If you could zoom far enough out, galaxies would form something like a cosmic web, with bright strands and knots separated by darker spaces. It is not a perfectly stirred soup. It is more like a vast foam, though perhaps less likely to spill on your jumper. But when astronomers average over very large distances, the universe appears broadly the same everywhere and in every direction. No great central heap, no obvious outer thinning, no direction that says this way to the middle, no cosmic signpost with an arrow and a cafe nearby. This broad sameness is sometimes described by saying the universe is homogeneous and isotropic on large scales. Those are formal words, but the idea is gentle enough. Homogeneous means that, when viewed on large enough scales, one region resembles another. Isotropic means that, from our position, the universe looks similar in every direction. The sky is not exactly identical wherever we look, but the largest patterns are astonishingly balanced. The deep universe does not look as if all galaxies are streaming away from one side of us toward another. It does not look as if we are near a boundary, with more universe in one direction and less in the opposite direction. Instead, it has a kind of large-scale fairness, a cosmic even-handedness. The universe is not tidy in the way a freshly made bed is tidy, but it is not arranged around a visible centre either. One of the strongest pieces of evidence for this comes from the oldest light we can observe, the cosmic microwave background. This is light released when the early universe cooled enough for atoms to form and for light to travel freely. Before that time, the universe was hot and dense, filled with a glowing plasma that scattered light again and again. It was not transparent. It was more like trying to see through a shining fog. Then, as the universe expanded and cooled, light was able to move freely, and that ancient glow has been travelling ever since. Today it reaches us from all directions, stretched into faint microwave radiation. It is everywhere in the sky, a soft afterglow from the early universe, as if the cosmos still carries the warmth of its childhood, though now very, very cooled down, like tea forgotten during a long philosophical discussion. What is remarkable is how uniform that ancient light is. It arrives from every direction with almost the same temperature. There are tiny variations, and those tiny variations matter enormously because they helped seed the formation of galaxies and clusters. But the overall smoothness is striking. If the universe had a simple center and edge like an explosion from a point into surrounding emptiness, we might expect the early glow to look very different from one direction to another. Instead, it surrounds us with extraordinary evenness. Again, that does not mean we are at the center of the glow. It means the early universe was hot and dense everywhere in the region that became our observable universe, and light from that early state is now reaching us from every direction. This can feel confusing because when we look at the cosmic microwave background, it appears to come from a spherical shell around us. That sounds very center-like, but the shell is not a physical shell with Earth in the middle. It is a surface of time. It is the farthest back we can see in every direction, the moment when the universe became transparent along each line of sight. Another observer elsewhere would see their own version of that surface centered on themselves. The ancient light would surround them too. Their sky would also carry a microwave glow from all directions. They might also, if they had evolved intelligence and a taste for gentle science videos, ask whether they were at the center. And they too would have to learn that the answer is no, but also yes in a very specific observational sense. Yes, they are at the center of what they see. No, they are not at the center of all that exists. There is a useful earthly comparison here. Suppose you are on a ship in the middle of the ocean. The horizon forms a circle around you. Every direction looks like an edge where sea meets sky. Another ship far away has its own horizon. The two horizons are different, yet neither marks the edge of the ocean. The horizon is a limit created by the shape of Earth and the height of the observer. It is real as an observational boundary, but not real as a physical ending. The cosmic horizon works in a similar spirit. It is not created by Earth being round in space, but by the finite speed of light, the age of the universe, and the way space has expanded. It is a genuine limit to what we can observe, but not a border of all existence. This helps explain why the universe can look centered from everywhere. Each observer is surrounded by their own horizon. Each observer sees distant galaxies receding in all directions because the expansion of space increases distances throughout the cosmos. Each observer sees ancient light arriving from the boundary of their visible past. The view is centered on the observer because observation is centered on the observer. That sounds almost too simple, like the answer to a riddle told by a very sleepy astronomer. But it is profound. It means the appearance of centrality does not prove central location. It proves that vision begins where the viewer is. We can see this even in ordinary life. If you stand in a crowd and everyone walks away from everyone else because the floor is somehow stretching, it would look to you as though people are moving away from you. But each person would see the same thing from their own position. No one needs to be the special middle. The pattern belongs to the expansion, not to any one person. Now, floors do not normally stretch, unless something has gone badly wrong with the building, but space can stretch. This is where our everyday intuition begins to run out of road. We're used to objects moving through space. We are less used to space itself changing the distances between objects, yet that is the heart of modern cosmology. A distant galaxy is not necessarily flying away from us through space, like a rocket leaving a launch pad. In many cases, the better description is that the space between us and that galaxy is increasing. The galaxy may be locally moving in its own way, tugged by nearby galaxies and clusters, but on the larger scales, the general pattern is expansion. The farther away a galaxy is, the more space lies between us, and the more expansion there is along the route. This makes the galaxy's light arrive stretched, shifted toward longer wavelengths. Astronomers use that stretching to infer how the universe is expanding. Again, from here, it looks as though everything far away is receding from us. From over there, it would look as though everything far away is receding from them. The universe is not pointing at Earth. It is behaving the same way from every location, at least on the largest scales we can test. There is a quiet humility in this. Our view is central to us, but not cosmically privileged. It is the same kind of humility we learned when Earth stopped being the center of the solar system, only now it is more subtle. We are not being moved from one center to another. We are learning that center is the wrong tool for the job. The universe does not need a middle point for every direction to look deep. It does not need an edge for us to have a horizon. It does not need to place us somewhere special for our sky to surround us. And yet, there is another side to this, one that feels almost generous. If every observer has an observable universe centered on them, then in a limited but real observational sense, every place is central to its own view. Not central in authority, not central in structure, central in perspective. A galaxy far beyond our reach is not on the outskirts of our universe in any grand universal sense. It is simply far from us. From its own view, we might be the distant faint object near its horizon, if our light could be seen at all. The universe does not have suburbs. It has relationships. Distance is always distance between things. Direction is always direction from somewhere. The map depends on the point from which you draw it. This becomes especially important when people ask where the Big Bang happened. The natural answer seems to be somewhere far away in the direction from which everything is expanding. But if every direction looks back toward the early hot universe, then the Big Bang was not an event located at one point in space. It happened everywhere in the sense that every region of today's space was once part of that earlier hot dense state. The beginning is not a distant place we could travel toward. It is a past condition of the whole observable universe. Wherever you are, looking far enough away means looking back toward that early condition. The Big Bang is not over there. It is back then. That phrase can be wonderfully clarifying. Not over there, but back then. It gently separates space from time in our imagination. We are not searching for a central crater, like investigators looking for where a cosmic firework went off. We are reconstructing an earlier era when the universe was hotter, denser, and more uniform. Every direction in the sky leads us backward toward that era because every direction contains light from the past. The center we are tempted to seek in space is really a beginning in time. And beginnings in time do not have to sit in a particular location the way a candle sits on a table. Of course, the universe was not perfectly smooth. Those tiny variations in the early glow eventually grew into the galaxies and clusters we see today. Gravity amplified small differences. Slightly denser regions attracted more matter. Over immense stretches of time, structure formed. Stars lit up. Galaxies gathered. Clusters assembled. Voids opened between them. The universe became textured, clumpy, and wonderfully interesting. If it had remained perfectly smooth, there would be no galaxies, no planets, no chemistry-rich worlds, no one lying awake at night asking whether the cosmos has a center. A little unevenness turns out to be quite useful. Too much smoothness would be dull. Too much chaos would be unhelpful. The universe, as usual, found a way to be complicated enough to keep everyone occupied. On smaller scales, we do see local centers. Earth has a center. The moon orbits Earth. Earth orbits the sun. The sun orbits the center of the Milky Way. The Milky Way belongs to a local group of galaxies. That group is drawn through space by the gravity of larger structures. These local motions are real. We are not sitting still. Nothing is politely fixed against the background while the rest of the universe performs for us. But these local centres do not add up to a universal centre. They are centres within systems, not the centre of all space. A kitchen has a sink, a town has a square, a galaxy has a dense core, but the whole Earth does not have a town square for every country, no matter how strongly some tourism boards might argue otherwise. This centreless nature of the universe asks us to be careful with scale. What is true nearby may not be true everywhere. What is helpful for a solar system may mislead us when applied to the cosmos. We are excellent at imagining objects inside space. We are less practiced at imagining all of space. An object can have a centre because it has boundaries and an outside. A planet has a surface in it. A ball has an interior and exterior. A galaxy has a dense region and a fading outskirts, though even galaxies can be messy at the edges. But the universe, if it includes all space, is not an object sitting inside a larger room. It is not clear that it has an outside in the ordinary sense. Without an outside, without a surrounding space into which it is placed, the idea of a centre becomes far less straightforward. This is why cosmologists often rely on models and analogies, not because the universe is exactly like a balloon, or raisin bread, or a loaf in an oven, but because our brains need a bridge from the familiar to the unfamiliar. The danger is that every bridge has railings, and sometimes we mistake the railings for part of the destination. A balloon has a centre in the surrounding room, but the surface itself does not have a centre on the surface. Raisin bread expands in an oven, but it has an outer crust, and the universe may not have a crust, delicious though that would be. These images help us see how everything can move away from everything else without a preferred central point, but they must be handled gently, like holding a sleepy cat. Useful, perhaps, but only if you do not squeeze too hard. So when every direction looks like the centre, what we are seeing is a combination of perspective and cosmic structure. We see a horizon around us because light has had limited time to reach us. We see galaxies receding in every direction because space expands everywhere. We see ancient radiation from all around because the early universe filled space, rather than exploding into space from one point. We see large-scale uniformity because the universe, on the greatest scales we can observe, does not appear to have a preferred location or direction. None of this makes Earth central in the old sense. It makes Earth one observing point in a universe where any observing point gets its own centered view. There is a lovely strangeness in that. The universe does not give us central status, but it does give us a center of experience. You're not at the middle of all space, but you're at the middle of the sky you can see. Every star you notice, every planet, every faint smudge of galaxy light reaches you here. Your body is small, your lifetime brief, and yet the observable universe is arranged around your line of sight simply because sight must arrive somewhere. In that modest sense, every observer is met by the cosmos, not crowned by it, not placed above it, met by it. And as this idea settles, we can begin to see why the old explosion picture is so persistent, and why it needs replacing carefully, not with scolding, but with better images. We need pictures that allow expansion without a central blast, motion without a cosmic starting point in space, and distance growing everywhere at once. That is where the familiar examples arrive, the balloon with dots on its surface, the loaf of raisin bread rising in the oven, the stretchy fabric that helps us think but also quietly tricks us if we take it too literally. They are gentle cosmic lies in the best possible sense, not because they are useless, but because they are only partly true, and the next step is learning exactly which part to keep. They are gentle cosmic lies in the best possible sense, not because they are useless, but because they are only partly true, and the next step is learning exactly which part to keep. Science is full of such images. A planet becomes a marble. An atom becomes a tiny solar system, which is not really right but does get the imagination moving before quantum mechanics walks in with a clipboard and ruins the simplicity. Space becomes a sheet. Gravity becomes a dip in that sheet. Time becomes a river, which is lovely until relativity reminds us that rivers do not usually slow down near black holes. These pictures are not the truth itself. They are handrails. They help us cross from what we know to what we are trying to understand. But if we grip them too tightly, we can forget they were only handrails and begin to mistake them for the building. The centerless universe almost always invites one of these handrails. The most famous is the balloon. Imagine gently a balloon with little dots drawn across its surface. Do not worry about the colour of the balloon, though if it helps, perhaps a sleepy blue one, the sort of balloon that would not startle anyone at a party. As the balloon inflates, the surface stretches. The dots move farther apart from one another. If you were a tiny creature living on the surface of the balloon, unable to see the inside or the outside, you would notice something interesting. Every other dot would seem to move away from you. The farther away a dot was, the faster it would seem to recede, because there was more stretching surface between you and it. And yet, on the surface itself, there would be no special central dot. No dot could claim to be the place from which all the others were fleeing. Every dot sees the same general pattern. Every dot can feel central, and none of them is. That is the part we want to keep. The balloon shows how expansion can make every location see other locations receding without requiring a center on the surface. It shows that the center of expansion need not be a place inside the space being considered. If the creatures live only on the surface, then the center inside the balloon is not part of their world. It is not a destination they can walk to. It is not a city hidden over the horizon. It is outside the surface they inhabit. For them, asking where the center is on the surface is like asking which wave in the ocean is the middle of wetness. The question feels as if it should have an answer, but the terms are slightly misbehaving. But here is where the balloon begins to lie, softly and politely. A real balloon expands into a room. It has rubber, air, an inside, an outside, and usually someone nearby making a face while trying to tie the knot. The universe, as far as modern cosmology describes it, is not expanding into a room. Space itself is expanding. There does not have to be an outside in the ordinary sense. There does not have to be empty space around the universe waiting for the universe to grow into it. That is difficult because all our everyday examples of expansion involve something growing into something else. A puddle spreads across a floor. Bread rises in an oven. Smoke expands through air. A crowd moves into an empty square. We are used to expansion meaning an object occupying more of a surrounding space. But cosmic expansion is not quite like that. It is the stretching of distances within space. So the balloon is helpful, and then it is misleading. It gives us a surface without a surface center, which is useful. But it also gives us a surrounding room, which can be dangerous. If we imagine the universe as the whole rubber balloon, sitting inside a larger room, we have smuggled in an outside view that cosmology has not given us. We have become, in our imagination, an observer standing beyond the universe, watching it inflate. It is a pleasing mental picture. It also gives us too much. There is no known cosmic living room from which to watch the universe expand, and if there were, one suspects the rent would be absolutely unreasonable. This is why scientists often say the balloon analogy works best if you focus only on the surface. The two-dimensional surface stands in for space, not the three-dimensional balloon as an object. The little surface creatures cannot leave the surface. They do not experience the center inside the balloon. Their whole geometry is the surface itself. Likewise, we cannot step outside the universe to see whether it has some higher dimensional shape or embedding. We describe the universe from within, using measurements made inside it. The balloon helps us imagine a space that can expand without having a center within that space. Then we must gently let go of the rest. Another favourite image is raisin bread. Picture a loaf of dough with raisins scattered through it. As the dough rises, every raisin moves farther from every other raisin. From the point of view of any one raisin, the others seem to recede. A raisin does not have to be at the centre of the loaf to see the others moving away. The expansion belongs to the dough itself. The farther away another raisin is, the more dough there is between them, and the more separation grows as the loaf rises. This is a cosy analogy, partly because it smells better than most cosmological models, and partly because bread is one of the few things that can make expanding space seem almost domestic. Again, the part to keep is the growing distance between all the embedded points. The raisins stand for galaxies, the dough stands for space. As space expands, galaxies that are not bound together by local gravity become more distant from one another. There is no need for galaxies to be flying away from a central blast point. They can be carried apart by the expansion of the space between them, much as raisins are carried apart by the rising dough. From each raisin, the pattern looks similar. Everyone gets to feel like the middle of the action, which is a charmingly democratic feature for baked goods, but raisin bread lies too. A loaf has an edge, it has a crust, it sits in an oven. It has a centre if you slice it carefully enough, although by that point the analogy is usually being eaten, and the lesson has lost some discipline. The universe may not have an edge like a loaf. It may be far larger than what we can see. It may continue beyond our observable horizon in every direction. If it is infinite, then the raisin bread image becomes especially awkward, because infinite bread is difficult to bake and even harder to store. If it is finite but unbounded, then it may have no edge in the ordinary sense, more like the surface of Earth has finite area, but no place where you can walk off the map into nothing. Either way, the loaf can accidentally make us imagine a cosmic crust, and that is not what the analogy is meant to do. The bread also suggests that galaxies are stuck in space the way raisins are stuck in dough. That is not quite right either. Galaxies can move through space. They are pulled by gravity. They orbit within clusters. They collide and merge. Our own Milky Way and the Andromeda Galaxy are moving toward one another, not away, because local gravity is stronger than cosmic expansion on that scale. The expansion of the universe is most apparent over enormous distances, between galaxy clusters and superclusters that are not gravitationally bound together. So the raisins are helpful as markers of expansion, but real galaxies are livelier than raisins. They do not simply sit there waiting to be spaced apart. They tug, swirl, merge, grow, and occasionally behave in ways that make astronomers apply for more telescope time. This is one of the gentle complications hidden beneath the simple pictures. Expansion does not mean everything is expanding in the same everyday way. Your body is not expanding with the universe. The chair beneath you is not swelling because space is stretching. Earth is not drifting away from the sun due to cosmic expansion. Atoms, people, planets, solar systems, galaxies, and many galaxy groups are held together by forces much stronger than the large-scale expansion of space. The expansion becomes important where gravity has not tied structures together. It is a feature of the universe on the grandest scales, not an excuse for your socks to be farther apart after laundry, though that mystery remains open in a different field of study. Then there is the image of dots on a stretchy rubber sheet. If you draw dots on a sheet and stretch the sheet evenly, all the dots move away from one another. From any dot, the others seem to recede. This has the advantage of being simple. It also avoids the balloon's obvious centre if you imagine a flat sheet. But it brings its own trouble. A sheet has edges. It is stretched by hands. It exists inside a room. It has a surface you can look down upon, and once again, we are standing outside the system and watching it from above like cosmic inspectors. That outside view is useful for teaching, but the real universe does not provide us with an official overhead angle. We are not above the sheet. We are dots within the geometry, trying to understand the stretching while sitting on it, which is a little like trying to study a carpet while being one of the threads. Perhaps the most important lesson from all these analogies is not that any one of them is perfect, but that each corrects a different mistake. The balloon corrects the idea that expansion needs a centre within the expanding space. The raisin bread corrects the idea that galaxies must be flying through space away from a blast point. The stretchy sheet corrects the idea that only the outer regions move while the middle stays fixed. Together they help us replace the explosion picture with an expansion picture, but none of them should be allowed to become too solid in the mind. The universe is not rubber, dough, or fabric. It is space and time, matter and radiation, geometry and gravity, all evolving according to rules that do not always fit neatly into kitchen objects. There is another reason these analogies can mislead. They often begin with a thing already existing and then expanding. A balloon exists before it inflates. Dough exists before it rises. A rubber sheet exists before it is stretched. So we may ask, quite naturally, what existed before the universe began expanding? What was it expanding into? Where was it located before? These questions are understandable, but they may carry assumptions from the analogy that do not apply. In the standard cosmological picture, the early universe was not a small object sitting somewhere, waiting to expand. It was an earlier, hotter, denser state of the universe itself. The phrase smaller universe can be misleading if it makes us picture a tiny ball floating in darkness. It is better, though still imperfect, to say that distances between points in space were smaller. All the space we can observe today was once compressed into a much hotter and denser condition. Not compressed at a location within space, but compressed in the sense that the scale of space itself was different. This is where our imagination begins to protest. It wants a picture. It wants to shrink the universe down to a glowing bead, place it in a black background, and then watch it burst open. That picture is dramatic. It is also exactly the picture that makes us ask for a centre. If the universe was a bead in darkness, surely the bead had a location. If it burst, surely the burst had a middle. But the black background in that image is not part of the model. It is something our minds add because we need contrast. We draw the universe inside emptiness because a drawing requires a page. The page becomes the false outside. The dark becomes the imagined pre-existing space. The centre of the drawing becomes the supposed centre of the cosmos. A simple illustration meant to help quietly sneaks in the wrong assumptions. Even the phrase Big Bang can be part of the trouble. It sounds like a bang. It suggests noise, force, flying debris, perhaps a cosmic smoke cloud and a few startled galaxies looking around wondering what just happened. But sound needs a medium, and the early universe was not an explosion heard from outside. There was no outside listener with a microphone. The name has stuck because it is memorable, and perhaps because humans enjoy dramatic labels. But it can nudge the imagination toward the wrong scene. It is less like a bomb going off in a room, and more like the entire room changing its scale. Except even that is not right, because the room is space itself, and there may not be walls. This is why cosmology is both fascinating and slightly rude. Just when you have found a helpful image, it asks you to give it back. Still, we should not be too hard on metaphors. They are not failures, they are tools. The trick is to ask what each tool is built to show. If you use a spoon to cut wood, the spoon is not being dishonest. You are simply asking too much from it. The balloon is not meant to explain every feature of the universe. It is meant to show how every point on a surface can move away from every other point without there being a centre on the surface. The raisin bread is not meant to explain the shape of the cosmos. It is meant to show how expansion can happen between many points at once. The stretchy sheet is not meant to explain the whole geometry of space. It is meant to help visualize distances increasing. Used gently, these analogies are wonderful. Used too literally, they become cosmic mischief. There is a quiet discipline in learning when to stop imagining. That may sound odd because science depends so much on imagination. But good scientific imagination is not just making pictures. It is knowing which parts of the picture are essential and which parts are decoration. When we imagine raisin bread, the raisins move in a part matter. The oven does not. When we imagine the balloon, the surface matters. The air inside does not. When we imagine a stretching sheet, the changing distances matter. The hands pulling the corners do not. The universe is generous enough to let us borrow images, but it charges a small fee in confusion if we keep the wrong pieces. Now, there is another subtle point. In the balloon analogy, the surface is curved. If a tiny creature travelled in one direction long enough on the surface of a balloon, it could eventually return to where it began, assuming it had excellent snacks and no fear of circumference. This shows one possible kind of finite but unbounded space. Earth works similarly on its surface. You can travel east without ever finding an edge. You may return to your starting point, tired and with a suspicious number of airport receipts, but you will not encounter a sign saying the surface ends here. Some cosmological models allow for a universe that is finite but unbounded in a higher dimensional sense. Others allow for a universe that is infinite and flat on the larger scales. Observations suggest the part we can measure is very close to flat, but that does not settle the full size or shape of everything. The universe could be larger than our observable patch in ways we cannot yet confirm. This is another reason not to demand a centre. Some spaces do not have centres in the way familiar objects do. The surface of Earth has no centre point on the surface. Earth as a sphere has a centre inside it, but that centre is not part of the surface world if you are only discussing locations on the surface. A flat infinite plane has no centre because every point is as good as any other. A finite unbounded space may have no edge and no special middle. The universe, depending on its global shape, may be centreless for reasons that are not strange once the geometry is understood, but feel strange because our daily lives are filled with bounded objects. We live among cups, rooms, roads, boxes, beds, and biscuits. Almost everything we handle has an inside and outside, and a place you can call the middle. The universe is under no obligation to behave like a biscuit, which is disappointing in one sense but scientifically useful in another. When people hear that space expands, they sometimes ask why galaxies do not expand too. If space itself stretches, should not everything stretch with it? This is where the raisin bread analogy can mislead, because raisins do not expand much while the dough does. It makes the answer look simple, but the real reason involves binding. Objects held together by forces resist expansion. Atoms are held together by electromagnetic forces. Planets are held together by gravity and the strength of matter. Solar systems are gravitationally bound. Galaxies are gravitationally bound. On these scales, local forces dominate. Expansion is not a magical stretching of rulers inside your desk drawer. It is a change in the large-scale distances between unbound regions of the universe. If your bed seems larger in the morning, that is probably not dark energy. It is more likely blankets, perspective, or a cat occupying 90% of the available space. The fact that local systems do not expand with the universe also helps us see why the centre question belongs to the larger scales. You can find centres inside bound structures. The solar system has a centre of mass, though it is not always exactly at the centre of the Sun. The Milky Way has a central region. Galaxy clusters have centres of mass. But the expansion of the universe is not centred on any of these local structures. It is woven into the large-scale geometry. Asking for the centre of universal expansion is not like asking for the centre of the Milky Way. The Milky Way is an object within space. The expansion concerns space itself. There is a very gentle mental exercise that can help. Imagine a grid drawn across the universe, not a physical grid, just a way of marking positions. Now imagine that over time, the spacing between the grid lines increases everywhere. Galaxies sitting with the grid become farther apart as the grid stretches. No one grid point has to be the origin of the stretching. The whole coordinate system changes scale. In real cosmology, things are more subtle, because galaxies have their own motions and gravity shapes the distribution of matter, but the basic idea is there. The expansion is not a wind blowing outward from a place, it is change in the scale of distances. If that feels less dramatic than a cosmic explosion, it is also more accurate, and frankly the universe has enough drama without needing fireworks. These analogies also teach us something about humility in language. We say galaxies are moving away from us, and that is often a useful shorthand. but it can suggest that we are stationary, and everything else is travelling outward through space. More carefully, the distance between us and distant galaxies is increasing because space is expanding. We say the universe began in a tiny point, but that can suggest a point located somewhere. More carefully, the observable universe was once in a much hotter, denser state, with far smaller distances between the regions that would later become widely separated. We say the edge of the observable universe, but that can suggest a physical rim. More carefully, it is a horizon, a limit to what light can have brought us. The words are not wrong exactly. They are compact. But compact words can carry folded confusion, and every now and then we have to unfold them carefully and smooth out the creases. Perhaps the best way to think about the balloon and the raisin bread is to treat them like bedtime stories told by physics. They are not literal histories. They are little scenes designed to quiet one mistaken picture and make room for a better one. The balloon says, "Do not look for a centre on the surface." The bread says, "Do not imagine all galaxies flying from one raisin." The sheet says, "Do not assume expansion needs a privileged point." Then, once they have done their work, they step aside. The real universe remains larger, stranger, and less easily sketched, which is inconvenient for diagrams but wonderful for curiosity. And after all these images have helped and misled us in equal measure, we can return to the deepest correction of all. The Big Bang was not the explosion of matter into space from a central point. It was the early expansion of space itself, from a hot, dense state that existed everywhere in the region we can now observe. That sentence may feel less cinematic than a great cosmic blast, but it is far more powerful. It means there is no central crater to find, no original location hidden beyond the galaxies, no direction in the sky that points toward the birthplace of everything. Every direction points back in time. Every region of space was once closer to every other region. The beginning is not a place we could travel toward with a fast enough rocket. It is an earlier condition of the whole cosmic story, and to understand why that matters, we have to gently set aside the bang and Big Bang and listen instead to what expansion is really telling us. The phrase Big Bang is memorable, dramatic, and just a little bit misleading, which is honestly quite impressive for only two small words. It sounds like something happened at a point, a great flash in a dark emptiness, a cosmic firework bursting outward, matter racing away from a central spark, galaxies flung like glitter across an enormous black room. It is a picture that arrives almost automatically because our minds know what bangs are. We have heard doors slam, balloons pop, thunder crack, fireworks burst, and saucepans fall from cupboards with the kind of enthusiasm normally reserved for orchestras. A bang begins somewhere. It expands into the space around it. It has a centre, a surrounding region, and, if it is close enough, someone nearby saying, "Goodness me, what was that?" But the Big Bang was not that sort of bang. It was not an explosion in space. It was not matter bursting outward into a waiting emptiness. It was the beginning of the expansion of space itself, or more carefully, the earliest hot, dense state from which our observable universe has been expanding and cooling ever since. That distinction is one of the most important in all of cosmology, and it is also one of the easiest to lose because the wrong picture is so vivid. An explosion is easy to imagine. Expanding space is much harder. Much. The universe seems to have given us a reality that refuses to fit neatly into the sort of scene one might draw on a napkin, which is inconvenient for napkins but rather good for wonder. When we picture an explosion, we picture objects moving through space. A firework sends sparks into the air. A volcano throws ash into the sky. A stone dropped into a pond sends ripples outward across water that was already there. In each case, something moves into a surrounding place. There is a before and after within an existing setting. The background is already available. The air is there, the sky is there, the pond is there. But the early universe was not a lump of material placed in a larger empty arena. Space was not sitting around like an unused ballroom. waiting for galaxies to arrive and begin the dance. Space itself is part of the story. The distances between points in space changed. The whole framework in which distance has meaning was evolving. This is why asking where the Big Bang happened can lead us astray. It sounds like a location question. Where was the event? Which direction should we point the telescope? Is it beyond the Milky Way? Beyond the most distant galaxies? Somewhere behind a cosmic curtain with a sign saying original site of universe, gift shop through the exit. But the better answer is that the Big Bang happened everywhere, in the sense that every part of the universe we can now observe was once part of that hot, dense early state. It was not over there, it was back then. The beginning is not a place at the far end of space. It is a time in the history of all the space we can see. That phrase, not over there but back then, is worth letting settle. It gently turns the mind away from a central location and toward an earlier condition. When we look far away in any direction, we look back in time because light takes time to travel. The farther we look, the earlier the universe appears. Eventually, in every direction, we reach the ancient glow of the early universe, stretched and cooled into the faint radiation that fills the sky. That glow does not come from one central point. It comes from all around us because the early hot universe was all around every observer. If there were astronomers in a distant galaxy, their ancient glow would also surround them. Not because they are at the centre either, but because the early universe was a state of space itself, not a fireball located somewhere within space. One reason this idea feels strange is that we often hear the universe was once very small. That can be true in a technical sense, but it can also be dangerously easy to picture the wrong thing. Small compared to what? If we imagine the universe as a tiny glowing ball floating in darkness, we have already placed it inside a larger space. We have given it an outside. We have given it a surface. We have given it a centre. Then, naturally, we imagine it exploding outward from that centre. But that dark background is not part of the model. It is something our imagination adds because pictures need contrast. A glowing ball needs a black page around it. The real idea is not that the whole universe was a little object sitting somewhere. It is that the distances between regions of space were once much smaller, and the density and temperature were much higher. This is a subtle shift, but it changes everything. Suppose you imagine many galaxies today, separated by vast distances. Now run the cosmic clock backward. The distances between those galaxies shrink. The universe becomes hotter and denser. Keep going backward, and the matter that would eventually form stars and galaxies is not yet arranged into those structures. It is a hot, dense, bright, rapidly changing state. Keep going back far enough, and even atoms cannot exist as stable atoms. Farther still, the physics becomes more extreme and less directly tested. But at no point do we need to imagine everything flying back toward one central point in pre-existing space. Instead, every region was closer to every other region. The scale of space itself was smaller. Of course, the phrase "every region was closer to every other region" can make the mind tug at its collar a bit. If the universe is infinite, how can it have been smaller? Infinity is a slippery guest at any dinner table. An infinite universe can expand, not by becoming infinite after being finite, but by changing the distances between points. It can be infinite now and still have been denser in the past. Every pair of widely separated locations can have been closer long ago, even if the total extent was already without an edge. This is not an easy thing to visualize, because we tend to picture expansion as something with boundaries pushing outward. But mathematics and observation allow a different kind of expansion, one where scale changes everywhere and no outer surface is required. If the universe is finite but unbounded, the story is also centerless in a different way. The surface of Earth is a helpful comparison, though only as a comparison. Earth has a finite surface area, but there is no edge on the surface. You can travel in one direction and eventually return without ever finding a boundary. The surface does not have a special center located on it. A finite universe could, in principle, have a geometry where space has no edge and no central point in the ordinary sense. We do not yet know the full global shape of the universe, and we should be honest about that. Our observations tell us about the part we can see, and they suggest that on large scales it is very close to flat. But the full universe could be far larger than our observable patch, and perhaps arranged in ways that do not fit comfortably into everyday pictures. The important part for tonight is that neither a finite unbounded universe nor an infinite universe requires a central explosion point. The evidence that led us to expansion did not come from finding debris flying away from a cosmic crater. It came from studying the light of galaxies. When astronomers observed distant galaxies, they found that their light was stretched in a way that suggested those galaxies were receding from us. The farther away a galaxy was, the greater this stretching tended to be. At first, this might sound as if we were at the middle after all, with galaxies fleeing in every direction. But the better interpretation is that space is expanding, and therefore distances are increasing everywhere. Any observer in any typical galaxy would see distant galaxies receding in much the same way. The pattern does not reveal Earth as the centre. It reveals expansion as a property of the universe. Think again of the raisin bread gently, without letting it take over the entire kitchen of your imagination. As the dough rises, each raisin sees the others moving away. No raisin has to be the centre. The receding motion is produced by the swelling of the dough between them. Now take away the crust, the oven, the smell, the baker, the tray, and unfortunately the butter. Keep only the idea that distances between embedded points increase. That is the useful part. Galaxies are not generally racing through space from a central blast. Over the larger scales, the space between distant galaxies is increasing, and that increasing distance stretches the light travelling through it. The early universe also left behind a remarkable afterglow. When the universe was young, it was hot and dense enough that light could not travel freely for long. Charged particles scattered it again and again, like headlights in a thick glowing fog. As the universe expanded, it cooled. Eventually conditions changed enough for atoms to form, and for light to travel freely across space. That ancient light has been travelling ever since. Today it arrives from every direction, stretched into a faint microwave glow. This glow is one of the strongest clues that the early universe was not an ordinary explosion in a pre-existing void. It is astonishingly uniform across the sky, with tiny variations that later grew into the structures we see today. It looks less like the remains of a blast from one place, and more like the cooled remnant of a hot, dense state that filled the observable universe. Those tiny variations are important. If the early universe had been perfectly smooth, gravity would have had no little irregularities to amplify. No dense regions would have grown into galaxies. No clusters would have formed. No stars, no planets, no sleepy listeners thinking about cosmic geometry while wrapped in a blanket. The universe needed slight unevenness. Not too much, not too little. Just enough for gravity to gather matter over immense spans of time. The oldest light shows us those early differences, tiny temperature variations across the sky, the seeds of later structure. But the overall smoothness remains the dominant feature. On the larger scales, the early universe looks almost the same in every direction. That is not what we would expect from a simple explosion with a central source and an outer edge. It may help to imagine what a true explosion into space would imply. If matter exploded outward from a point, then there would be a meaningful centre. Material closer to the centre and material farther from the centre would occupy different roles. Observers in different places might see the universe differently depending on whether they were near the centre or near the edge of the expanding cloud. There might be a direction toward the origin and a direction away from it. The distribution of matter could show a pattern that points back to a location. But our universe does not display that kind of large-scale arrangement. Instead, it appears broadly uniform on sufficiently large scales, and the expansion looks the same in all directions from every ordinary location. That is a major clue that the Big Bang is not a blast from a place. The word ordinary matters here, not because some locations are boring, though some intergalactic regions do seem to have very little going on socially, but because cosmology assumes there is no special privileged location on the larger scales. This idea is often called the cosmological principle. It says that when viewed on sufficiently large scales, the universe is roughly the same everywhere and in every direction. That does not mean every place is identical. A star is not the same as a void. A galaxy cluster is not the same as empty-looking intergalactic space. Your pillow is not the same as a neutron star, which is fortunate for several reasons. It means that when we average over enormous distances, no location appears uniquely central or special. This principle is supported by observations, and it is one of the foundations of modern cosmology. The Big Bang, then, is not a point in space, but a boundary in our description of time. It is the name we give to the early hot, dense expansion from which the observable universe developed. When we follow the evidence backward, galaxies were closer together, matter was denser, radiation was hotter, and the universe was more uniform. The farther back we go, the more extreme the conditions become. Eventually, our current theories reach limits, and we must be careful. We do not have a complete tested description of the absolute first instant, if that phrase even makes sense. Physics near the earliest moments likely requires a theory that joins gravity with quantum mechanics in a way we do not yet fully possess. So when someone says the Big Bang was the beginning of everything, it is good to pause softly and say, perhaps, but our tested description really tells us about the universe evolving from an extremely early hot dense state. Beyond that, there is still mystery. Cosmology is not embarrassed by mystery. It keeps a notebook for it. That mystery does not bring back a center. Not knowing everything about the earliest moment does not mean we should imagine a fireball in empty space. The evidence we do have points strongly away from that picture. Space itself has expanded. The early universe was hot and dense everywhere in the observable region. The oldest light arrives from all directions. Distant galaxies recede in a pattern consistent with expanding space. No central location has appeared in the data. The missing center is not a gap in the map. It is part of what the map is telling us. There is also a common question about what the universe is expanding into. It is a fair question, because every expansion we see in daily life seems to require a surrounding area. A balloon expands into air, bread expands into an oven, a crowd expands into a square. But in cosmology, expansion does not require an outside space. The universe is not necessarily moving into anything. Distances within the universe are increasing. If the universe includes all space, then there may be no external spatial arena into which it grows. That sounds strange because our language was built for everyday objects, not for all of reality. Asking what space expands into may be like asking what is north of the North Pole. The question uses familiar words, but beyond a certain point the familiar words stop connecting to the situation in the usual way. This does not mean the question is silly. It means the question is carrying an assumption. It assumes expansion must be expansion into something larger. That assumption works beautifully for balloons and puddles. It may not apply to space itself. When cosmologists say space expands, they mean that the distances measured between far separated objects increase over time according to the geometry of the universe. They do not mean there is a cosmic empty warehouse outside the universe waiting for more universe to arrive. There might be deeper theories involving larger structures, dimensions, or multiverse ideas, but those are not required to explain the observed expansion. We should not add an outside just because our imagination wants somewhere to stand. There is a gentle irony in all this. The Big Bang sounds like the most explosive, central, dramatic event imaginable, yet its real lesson is that there is no central place. The beginning, as far as the observable universe is concerned, was everywhere. Every galaxy, every star, every planet, every atom in your body traces its history back to a time when the universe was hotter and denser. Not because all things flew from a distant centre to reach us, but because the space containing everything has changed. The story of the universe is not debris travelling away from a blast. It is a cooling, expanding cosmos in which structure slowly emerged. To bring this closer to home, consider the atoms around you. The matter in your body was not sitting near some central explosion waiting to be thrown across space toward Earth. Much of it formed later inside stars through nuclear processes, and some of it was scattered by dying stars into interstellar space, before becoming part of new stars, planets, oceans, cells, and perhaps a person listening in bed. Your atoms have histories within the evolving universe, but their cosmic origin is not a single launch point. They belong to a universe whose whole visible region was once in a hot, dense state. The beginning is not far away from you in space. In a deep historical sense, you are made from the unfolding of that beginning right here. This also changes how we imagine looking outward. When a telescope sees a distant galaxy, it is not seeing something closer to the edge of an explosion. It is seeing a younger version of that galaxy because the light has taken so long to arrive. When a telescope observes the ancient microwave glow, it is not seeing the outer wall of the universe. It is seeing the early universe as it was along that direction when light first travelled freely. Every direction becomes a path into the past. The farther we look, the earlier the story. The sky is not a map of places arranged around a central blast. It is a record of time layered by distance. This is one reason cosmology can feel so calming and so dizzying at once. It removes the dramatic centre, but gives us a grander continuity. The universe did not begin somewhere else and send fragments outward until eventually one fragment became home. The universe has been evolving everywhere, and home is one small result of that evolution. We are not sitting near the edge of an old explosion. We are living inside the expanded, cooled, structured aftermath of an early state that included the region where we now are. The Big Bang is not a distant event from which we are separated by space. It is part of the past of every place. Of course, everyday speech will continue to say the universe began with a bang. It is too catchy to retire. People will keep showing animations of tiny glowing points expanding into darkness because they are simple and visually satisfying. There is nothing wrong with beginning there, as long as we do not end there. The first picture opens the door. The better picture invites us inside and rearranges the furniture. The universe began not as a bomb in a void, but as a hot, dense state of space itself. It expanded not from a centre, but everywhere. It cooled not at the edge, but throughout. It formed structure, not by scattering debris outward, but by allowing tiny early variations to grow under gravity. And once that becomes clear, the centre disappears in a very natural way. If the Big Bang happened everywhere, then no place is the special origin. If space itself expanded, then galaxies do not need to be flying away from a central point. If every observer sees distant galaxies receding, then the pattern belongs to the expansion, not to the observer. If the oldest light surrounds every observer, then the surrounding glow is not a shell around Earth, but a horizon of time. The entire centre-seeking instinct begins to soften. We stop looking for a location and start thinking in terms of history, geometry and perspective. This is where the next part of the story quietly waits. Once we set aside the explosion picture, we can ask what expansion really means if it happens everywhere at once. How can every galaxy see other galaxies moving away? Why does greater distance mean faster recession in the large-scale pattern? Why do local systems like galaxies remain together while the space between distant clusters grows? And how can expansion have no middle, no edge, and no preferred direction, yet still be measurable from here in our small corner of the cosmos? To answer that, we have to follow the idea that space is not stretching from somewhere, but stretching between everywhere, carrying every ordinary observer into the same strange and centreless view. Space is not stretching from somewhere, but stretching between everywhere. And that is the idea that quietly changes the whole picture. It asks us to stop imagining the universe as a cloud of galaxies flying away from one original place, and instead to imagine the distances between faraway galaxies growing because the space that separates them is changing over time. Not changing in a way you could feel in your bedroom, thankfully. Your pillows are not drifting apart because of cosmic expansion, though they may still manage to vanish in the night by methods unknown to physics. The expansion of the universe is not something that pulls apart everything equally on every scale. It is a large-scale feature of space, most clearly seen across the enormous distances between galaxies and clusters of galaxies that are not held together tightly by gravity. This is one of the first things to get settled. Expansion does not mean everything expands. Earth does not expand. The solar system does not expand. The Milky Way does not expand in the same way the universe does. Atoms do not grow larger. Rulers do not stretch while pretending to measure normal distances. If that were happening, we would have a very difficult time noticing anything, rather like trying to measure a growing table with a growing tape measure while sitting in a growing chair and wondering why breakfast feels more ambitious than usual. Local structures are held together. Electromagnetic forces hold atoms and molecules together. Gravity holds planets, stars, solar systems, galaxies, and many galaxy groups together. On those scales, the forces binding objects are strong enough to resist the general expansion of space. The expansion becomes visible when we look across distances so huge that local binding no longer dominates. Between distant galaxy clusters, over hundreds of millions or billions of light years, the average distance grows with time. That is where the universe reveals its large-scale behaviour. It is not that each galaxy has a tiny engine pushing it away from every other galaxy. It is not that galaxies are sailing through a fixed background like ships leaving a harbour. It is that the background itself, the geometry of space, changes so that the separation between unbound regions increases. That is a strange sentence if you're used to thinking of space as empty nothingness. But in modern physics, space is not merely a blank stage. It has structure. It can curve. It can expand. It can take part in the story. A helpful way to begin is with the idea of distance markers. Imagine many galaxies spread across the universe, each one marking a place in space. Over time, the distances between widely separated markers increase. From any one marker, the others seem to move away. The farther away another marker is, the more space lies between them, and the more expansion happens along that distance. So the most distant markers appear to recede faster than nearby ones. This does not mean your own marker is the centre. It means that expansion accumulates with distance. More space between two galaxies means more stretching of that separation. Every observer sees the same kind of pattern because the expansion belongs to the space between observers, not to one special observing point. This is the heart of the centerless expansion. If you stand in one galaxy and measure distant galaxies, you find that faraway ones are generally receding. If someone in another galaxy does the same, they also find distant galaxies receding from them. Neither of you is at the true center. Both of you are measuring the same expanding universe from different locations. This feels odd only because we are used to motion having a clear source. If people in a crowd all walk away from you, you may assume you have said something alarming. But if the floor itself stretches evenly in all directions, then everyone sees everyone else moving away, and no single person caused the retreat. Admittedly, a stretching floor would be a serious architectural concern, but as a mental picture it helps. Cosmic expansion is often described as uniform on the larger scales. That does not mean the universe is perfectly smooth in every small detail. It clearly is not. There are galaxies, clusters, filaments, and voids. There are regions full of matter and regions that are emptier than average. But when astronomers zoom out far enough, the overall pattern appears similar from place to place. The universe does not look like a dense ball with a thinning edge. It looks like a cosmic web spread throughout space. If the expansion began from a central explosion, we might expect a strong pattern pointing back to a middle. Instead, the expansion appears to be everywhere, with every distant region participating in the same general stretching. This is where the phrase "from everywhere" needs care. It does not mean that each galaxy is a separate origin of expansion. It means no galaxy is the origin. The expansion is not launched from a point. It is a property of the whole large-scale universe. In the past, the distances between galaxies were smaller. In the future, the distances between unbound galaxies will be larger. At every stage, observers inside the universe describe the same basic trend from their own point of view. There is no outside place where the expansion begins. There is no central motor. The universe is not a machine with a hidden axle. It is more like a changing network of distances, though even that picture is only a tool and should not be invited to run the entire household. One reason this becomes difficult is that space itself feels passive in daily life. We move through it, we put things in it, we cross it, we measure it. Space seems like the quiet container of events, not an actor in them. But general relativity changed that view. It showed that space and time are connected with gravity and matter. Massive objects influence the geometry around them. The universe as a whole can have a changing geometry. Expansion is not an added motion placed on top of space. It is built into the way distances evolve over cosmic time. The galaxies are not simply moving through a static stage. The stage itself is changing size between distant actors, which is not the sort of thing most theatres advertise, but would certainly make for an interesting evening. The light from distant galaxies gives us evidence of this expansion. As light travels through expanding space, its wavelength is stretched. Astronomers detect this as a shift toward the red end of the spectrum. That stretching tells us how much the universe has expanded while the light was on its way. A nearby galaxy may show only a small effect, while very distant galaxies can show a much larger one. Because their light has travelled for a longer time through a universe whose scale has changed, this is not just a measurement of speed in the everyday sense. It is a record of how the universe has expanded between the time the light was emitted and the time it reached us. It is tempting to picture the galaxy itself racing away through space faster and faster, like a motorbike on a very ambitious road. But for distant galaxies, the recession we infer is often better understood as the increase of distance due to expanding space. That difference matters especially at very large distances, where space can expand in such a way that extremely distant regions become unreachable, not because they are moving locally through space faster than light in the ordinary sense, but because the space between us and them is increasing too quickly for light emitted now to ever close the gap. This sounds like a loophole designed by a mischievous universe, but it follows from the fact that relativity limits local motion through space, while the expansion of space itself is a different kind of behaviour. That idea can be unsettling, so let us bring it down gently. Imagine an ant walking across a long rubber path while the path is being stretched. If the ant is close to you, it may still reach you because it has little stretching path to cross. If it is very far away and the path stretches fast enough, the ant may never arrive. Even if it keeps walking steadily, the ant is not breaking any walking rules. The path is changing beneath it. In the universe, light is the fastest messenger we know, but if enough expanding space lies between us and a distant region, light from that region may be delayed, stretched, or, in some cases, never reach us if emitted too late. The universe can therefore have horizons, not because there is a wall at the edge, but because expansion and time together limit what can be seen or reached. This is one reason the observable universe is not the whole universe. We see only the region from which light has had time to reach us since the early universe became transparent, shaped by the expansion that occurred while that light travelled. Beyond that observable region, there may be much more universe, possibly far more, possibly so much more that our visible patch is a small sample of a far larger whole. But because the expansion affects what light can reach us, we have a horizon. It surrounds us in every direction. It makes us the centre of our observable universe. Yet again, not the centre of all space, just the centre of our view. Expansion everywhere also means that there is no edge moving outward into emptiness. This is another hard picture to release. If the universe expands, something in us wants to ask where the outer surface is. If it is getting bigger, surely it must be getting bigger into something. But the expansion described by cosmology is not the growth of an object into a surrounding void. It is the increase of distances within the universe. If the universe is infinite, it can expand while remaining infinite, because the spacing between points grows. If the universe is finite but without an edge, it can expand in a way that changes its scale without needing an outer boundary. Either way, no cosmic rim is required. There may be no last galaxy beyond which there is simply a dark wall labelled end of universe, which is probably for the best, because someone would immediately try to sell tickets to it. To say expansion is everywhere is also not to say it is equally noticeable everywhere. Near us, gravity complicates the pattern. The Milky Way and Andromeda are moving toward each other because they are gravitationally bound within our local group. Nearby galaxies can approach, orbit, or interact depending on local gravitational pulls. If you measured only nearby galaxies, you would see a messy local dance. Some are moving away, some toward us, some sideways, some involved in long complicated relationships with neighbours. It's only when you look beyond these local gravitational neighbourhoods that the clean pattern of cosmic expansion becomes clear. The universe is not a perfectly smooth set of dots drifting apart. It is clumpy matter embedded in an expanding background, with local gravity stirring the clumps. This mixture of local motion and large-scale expansion is important. It keeps us from imagining expansion as a simple outward flow of everything. Galaxies have histories. They form from collapsing gas. They merge. They grow. Their stars orbit within them. Clusters pull galaxies into great swarms. Dark matter shapes large structures. On top of all this, or rather beneath it as the large-scale setting, space expands. The result is not a tidy mechanical toy, but a universe with many layers of motion. A star can orbit within a galaxy. A galaxy can move within a group. A group can drift within a larger cosmic flow. And far beyond the bound systems, the expansion of space increases separations across the cosmic web. It is motion within motion, structure within expansion, a very grand arrangement that somehow still leaves us struggling to find our keys. The reason expansion can look the same from many places is that there is no preferred background grid with a special central point. Cosmologists often use coordinates to describe the expanding universe, but the coordinates are bookkeeping, not physical rails nailed to reality. You can choose a way of labelling positions that expands along with the universe. In that description, galaxies that are carried with the general expansion remain at fixed coordinate labels, while the scale between the labels grows. This sounds like a trick, but it is just a way of separating the expansion of space from local motions through space. The important point is that no coordinate label is the privileged one. The labels are tools. The universe does not care what numbers we write in the margins. This also helps answer why the expansion does not point back to Earth. If we choose Earth as our reference point, other distant galaxies recede from us. If we choose another galaxy as the reference point, other distant galaxies recede from it. The mathematics changes viewpoint without changing the physical situation. It is like describing the layout of a town from your house or from the train station. The directions and distances in your description change, but the town itself has not crowned either location as the sacred centre of groceries and post offices. In cosmology, the situation is grander, but the principle is similar. A viewpoint can be central to a description without being central to reality. There is a quiet lesson here about how science handles perspective. It does not ask us to pretend we have no viewpoint. We always have one. We observe from Earth, at a particular time, with particular instruments, looking through our own galaxy and its dust and motion. Science asks us to identify what belongs to our viewpoint and what belongs to the universe. The fact that galaxies appear to recede from us in all directions belongs to our viewpoint, but the rule that every observer would see the same large-scale pattern belongs to the universe. The fact that our observable universe surrounds us belongs to our viewpoint, but the existence of horizons caused by light travel time and expansion belongs to the universe. Distinguishing these is how we avoid mistaking our window for the whole house. The expansion also changes how we think about the past. If distant galaxies are farther apart now than before, then long ago the observable universe was denser. Not denser in one place, but denser everywhere. The early universe was not a crowded centre surrounded by emptiness. It was a hot, dense state throughout all the space that has since expanded into the observable universe. As time passed, space expanded, matter cooled, particles formed atoms, gas gathered under gravity, stars ignited, galaxies assembled, and eventually chemistry became interesting enough to produce planets, oceans, and beings capable of worrying about deadlines. The expansion is therefore not merely a background fact. It is part of how the universe evolved from a hot, smooth beginning into the structured cosmos we see. There is something elegant about a universe where every place can tell the same large-scale story. From any ordinary galaxy, looking back far enough means seeing an early hot universe. Looking around means seeing galaxies receding on large scales. Looking at the oldest light means seeing a surrounding glow from the time when light first travelled freely. The details differ, because each location has its own nearby galaxies and local history, but the broad pattern remains. This is what it means for the universe to have no preferred centre. The laws and large-scale structure do not single out one location as the starting point. The cosmos is not arranged like an empire with a capital. It is more like a vast fabric whose pattern repeats statistically across regions. Though again, we should be careful, because fabric has edges and someone always wants to ask what colour the curtains are. Now, expansion is not only continuing, it is also changing over time. Observations show that the expansion of the universe is accelerating. This means that, on the largest scales, distant galaxies are not merely becoming farther away, but the rate at which the separation grows is increasing. The cause is usually described in terms of dark energy, a name that sounds as if it should come with dramatic music, but really marks a deep scientific puzzle. Dark energy is not a substance we have scooped into a jar. It is a term for whatever is driving this accelerated expansion, or however our best model accounts for it. The details remain one of the major open questions in cosmology. But even here, acceleration does not introduce a centre. It affects the large-scale expansion everywhere. It does not push outward from a location. It changes the future history of distances across the universe. This accelerated expansion has a distant consequence. Over enormous stretches of time, galaxies that are not bound to us may move beyond our ability to observe them. Their light may become increasingly stretched and faint. The universe visible to future observers could become emptier, not because galaxies vanish from existence, but because expansion carries them beyond reachable horizons. A civilization far in the future, if it lived in a galaxy like ours, might look out and see far less evidence of the wider cosmos. The great cosmic web could fade from view, leaving only the local bound group of galaxies. That is a strange thought. The universe has not only a history, but also changing access to its own history. What can be known depends on when and where observers arise. We happen to live at a time when the evidence for expansion is still written across the sky, which is fortunate and perhaps a little flattering, though we should not let it go to our heads. The centreless expansion therefore gives us a universe that is both democratic and selective. Democratic because no ordinary location is the centre. Selective because every observer has a limited view. You see from where you are, and the universe gives you a horizon. Another observer sees from elsewhere and receives a different horizon. There is no single, complete visible map available from inside. We build our understanding by recognizing the shared rules behind different possible views. That is one of the quiet achievements of cosmology. From a small planet around an ordinary star using light that has crossed enormous distances, We infer not that we are central, but that the same expansion would be seen from almost anywhere. It is worth pausing on how deeply this reverses the ancient instinct. Once, the fact that the sky seemed to move around us was taken as evidence that we were central. Now, the fact that distant galaxies seem to recede from us in all directions is understood as evidence that no one is central. The same kind of appearance, everything arranged around the observer, leads to the opposite conclusion once we understand the geometry. That is rather wonderful. The universe did not become less centered because the view changed. Our interpretation matured. We learned that being surrounded is not the same as being special. A horizon surrounds you because you're looking from somewhere. Expansion surrounds you because everyone is looking from somewhere inside an expanding cosmos. So when we say expansion everywhere, from everywhere, we're not describing a burst from every galaxy, nor a set of explosions sprinkled across space. We're saying that the increase of distance is built into the large-scale structure of the universe. Every sufficiently distant unbound region participates. Every ordinary observer sees others receding. Every direction leads outward in space and backward in time. The center is absent not because we have failed to find it, but because the expansion has no need for one. It is not a missing landmark. It is a feature of the kind of universe we inhabit. And this brings us naturally to the edge of what we can see. If expansion happens everywhere, and if light takes time to reach us, then our view must be limited by a cosmic horizon. Not an edge of the whole universe, not a final wall, not the place where galaxies stop and nothing begins, but the boundary of our observable patch. Around us lies a sphere of ancient information, shaped by the age of the universe and the expansion of space. Within it are galaxies at many stages of history, some nearby and mature, some distant and young, some so far away that their light began travelling before Earth existed. To understand why this visible region can look like a centred sphere, without making us the centre of everything, we have to follow the light itself, from galaxies, through expanding space, toward the small blue world where someone, perhaps under a blanket, is quietly listening. Follow the light itself, and the universe becomes less like a place we look across and more like a story arriving late. Every glow in the night sky has travelled before it reached us. Every star, every galaxy, every faint smudge gathered by a telescope is not only somewhere far away, but also some time ago. The sky is not a live broadcast. It is a collection of messages, each sent at a different moment, each delayed by distance, each arriving with the quiet patience of light. Even the moon, so close by cosmic standards that it feels almost neighbourly, is seen as it was a little earlier. The sun is seen as it was several minutes ago. The nearest stars are seen years in the past. Distant galaxies are seen as they were millions or billions of years ago, long before any human eye existed to receive them, long before anyone had misplaced a pair of glasses and blamed it on the expansion of space. This is the first gentle key to the observable universe. To look far away is to look back in time. The universe does not hand us a single present moment spread neatly across all distances. It gives us layers of history. Nearby space is recent. Faraway space is ancient. The most distant light we can detect began its journey when the universe was very young, before galaxies had formed in the familiar way, before stars had filled the darkness with heavy elements, before planets like Earth had any chance of existing. When we build large telescopes and aim them into deep space, we are not simply increasing the size of our view. We are extending our memory. We are letting the universe show us younger and younger versions of itself. But there is a limit. Not because our telescopes are lazy, though they do require a great deal of care, cooling, alignment, scheduling, and the occasional anxious committee meeting. The limit exists because the universe has a finite age, light travels at a finite speed, and space has been expanding while light travels. There has only been so much time for light to reach us. Regions too distant have not yet had time to send us their signals, or the signals have been stretched and delayed by the expansion of space. in ways that place them beyond our current observational reach. This boundary is what we mean when we speak of the observable universe. It is the portion of the universe from which light or other signals has been able to reach us by now. The observable universe is not the whole universe. This cannot be said too gently or too often. It is our visible patch, our cosmic neighbourhood in the broadest possible sense. It is everything we can, in principle, receive information from at this time. It is centred on us because we are the observers. If you were in a distant galaxy, your observable universe would be centred on you. You would see your own surrounding sphere of reachable light. Some of it might overlap with ours, if you were not too far away. Some of it would include regions forever hidden from us. And some of what we see might be beyond your horizon. This is not because the universe is arranged around whoever happens to have a telescope. It is because observation begins at the observer and light takes time to arrive. Imagine standing in a dark forest with a lantern. The circle of light around you is centred on you, but you are not the centre of the forest. Move to another place, and the lit circle moves with you. The darkness beyond is not necessarily empty. It is simply beyond what your lantern currently reveals. Now replace the forest with the universe. Replace the lantern with the history of light arriving from all directions, and replace the nearby trees with galaxies so distant that their light began travelling before the sun existed. The picture is not exact because cosmic light travels toward us rather than outward from our hand, and space itself is expanding, which forests rarely do unless one has eaten a very questionable mushroom. Still, the idea helps. The visible region is not the whole territory. It is the part connected to us by light. Galaxies are the great markers in this visible region. They are islands of stars, gas, dust, dark matter, and motion, scattered across the cosmic web. Some are spirals like our Milky Way, with arms curling around a bright central region. Some are elliptical, older-looking swarms of stars shaped more like glowing clouds or stretched spheres. Some are irregular, disturbed by gravitational encounters, mergers, bursts of star formation, or perhaps just cosmic temperament. A galaxy is not a single object in the simple sense. It is a vast gravitational community, a structure held together over immense timescales, full of stars orbiting, gas clouds collapsing, black holes feeding or sleeping, and new suns forming from old material. When we look at galaxies across deep space, we see not only where matter has gathered, but how the universe has grown structure from its early smoothness. Nearby galaxies show us the universe as it is relatively recently. Distant galaxies show us younger eras. The farther away we look, the more galaxies appear as they were when the universe was still building itself into the form we recognise today. Some distant galaxies look small, clumpy and chaotic because we are seeing them when they were young, before long histories of mergers and star formation shaped them into mature systems. Others blaze with intense starbirth, producing new stars at rates that would make a calm little galaxy like ours look as if it were taking a quiet afternoon nap. Deep observations reveal a universe that changes with time. Galaxies are not fixed decorations pasted onto space. They are evolving systems, and the observable universe lets us see that evolution spread across the sky. This is one of the strangest gifts of astronomy. We cannot watch a single galaxy evolve for billions of years, because our own lives are far too short, even if we take vitamins and avoid unnecessary meetings. But we can look at many galaxies at different distances, and therefore at different ages. Nearby galaxies show later stages. Faraway galaxies show earlier stages. It is like walking through a gallery where each room contains portraits from a different period of the same long family history. No single picture tells the whole story, but together they reveal change. The observable universe is not merely a map in space. It is a museum of cosmic time. The word horizon enters because there is a boundary to this museum. A horizon does not necessarily mean an edge where something ends. On Earth, The horizon is the limit of what you can see from where you stand. It follows you. It depends on your position and height. Ships do not disappear because they fall off the world when they cross your horizon. They simply move beyond your line of sight. The cosmic horizon is similar in spirit, though formed by time, light, and expansion, rather than by the curve of Earth beneath your feet. It marks the boundary of what can have sent us information by now. Beyond it, there may be more galaxies, more voids, more cosmic web, perhaps more than we can imagine. But their light has not reached us, and so they are not part of our observable universe. There are different kinds of horizons in cosmology, and they can sound rather formal, but the underlying ideas are gentle. One horizon concerns how far we can see into the past. There is a most distant visible surface, not a solid surface, but the earliest light that can reach us from the time when the universe became transparent. Before that, the universe was filled with a hot charged fog that scattered light constantly. It was not dark, but it was opaque. Light could not travel freely through it. When the universe cooled enough for atoms to form, light was finally able to stream across space. That ancient light still fills the sky today, stretched by expansion into a faint microwave glow. It comes from every direction, forming the oldest image of the universe we can observe. This glow is often described as the afterglow of the early universe, but even that phrase needs a little care. It is not the light from a fireball located far away in one direction. It is light from an early stage of the universe itself, arriving from all around because every direction leads back toward that time. We see it as a surrounding sphere only because we are observing from here. Another observer elsewhere would see their own surrounding ancient glow. They too would be at the centre of their visible sphere. The glow is not a shell around Earth. It is the limit of our view into the young universe. That ancient light is almost the same in all directions, with tiny variations. Those tiny differences are precious. They are the faint traces of early density variations, the little unevennesses that gravity would later grow into galaxies and clusters. If the early universe were a perfectly smooth blanket, nothing much would clump. No galaxies would form. If it were too uneven, the cosmos might have become chaotic in a different way. Instead, it had the right kind of slight texture. Enough for structure, enough for stars, enough for planets, enough for chemistry, enough eventually for someone to whisper into a microphone about the centerless universe, while another person listens in the dark. It is hard not to feel a little fond of those tiny variations. Galaxies themselves do not fill the observable universe evenly like dust in a sunbeam. They form a cosmic web. This web is one of the grandest structures we know. Gravity pulls matter into filaments and walls, while vast voids open between them. Galaxy clusters gather at the knots, where filaments meet. The pattern looks almost biological in some images, like a network of glowing cells or fine threads. But it is not alive in the usual sense. It is gravity shaping matter over billions of years, drawing from the initial variations in the early universe, guided by dark matter and influenced by expansion. The cosmic web tells us that the universe is not simply a smooth fog of galaxies. It has architecture, though not architecture with a central hall, reception desk, or clearly marked toilets. Yet even this structure does not give the universe a centre. A web can have knots everywhere. A foam can have bubbles everywhere. A forest can have clusters of trees without having one sacred middle tree from which all shrubbery receives permission. On large enough scales, the cosmic web appears statistically similar in different regions. There are local differences, of course. Our own location belongs to the Milky Way, which belongs to a local group of galaxies, which lies within larger flows and structures. But none of these local arrangements marks the centre of everything. They are addresses within the cosmic web, not the centre of the cosmic map. The observable universe also has a size, but that size can be confusing. You might think that if the universe is about 13.8 billion years old, then the farthest things we can see should be about 13.8 billion light years away. That sounds sensible, but space has expanded while the light was travelling. The regions that emitted the oldest light are now much farther away than they were when that light began its journey. This is one of those details where the universe politely refuses to match the first answer on the worksheet. Light travel time and present distance are not the same in an expanding universe. We see ancient light from places that have since moved, or more carefully, whose distance from us has increased as space expanded. This means the observable universe is larger than a simple light travel time picture would suggest. The light has been on the road for nearly the age of the universe, but the road itself has stretched during the journey. It is rather like walking across a carpet while someone keeps adding more carpet between you and your destination. You may still arrive, depending on how much carpet and how quickly it is added, but the final distance can be very different from the distance when you started. Light from the early universe has reached us, but the matter that emitted that light is now far beyond the distance you might guess from travel time alone. This does not mean the light travelled faster than light. It means the distance between us and the source changed while the light was travelling. Local motion through space still obeys the usual cosmic speed limit, but the expansion of space can increase distances between very far separated regions in ways that do not fit the ordinary picture of objects moving through a fixed background. Again, the problem is not that physics is contradicting itself. The problem is that our everyday mental furniture was built for rooms, roads, and bicycles, not for expanding space across billions of years. The observable universe therefore has layers, nearby galaxies, recent and detailed, farther galaxies, younger and fainter, more distant galaxies seen when the universe was much younger. Beyond the earliest galaxies, the ancient microwave glow from the time when light first travelled freely. Before that, an opaque era we cannot observe with ordinary light. We can infer, model and test through indirect evidence, but we cannot simply look through that glowing fog with a telescope that detects light as we know it. The universe has given us a visible childhood photograph, but not a direct baby video from before transparency. Scientists naturally are trying to learn as much as possible from the photograph, including the lighting, the background, the small variations, and whether the universe blinked. There are other messengers besides light, and they add to the story. Neutrinos, gravitational waves, and other signals may allow us to probe eras or events that light cannot reveal directly. Gravitational waves, ripples in the geometry of space and time, have already opened a new kind of astronomy for merging black holes and neutron stars. In principle, ancient gravitational waves could carry information from extremely early times, though detecting such signals is extraordinarily difficult. Neutrinos also come from processes where light may be blocked or delayed. The observable universe is not only what telescopes see in visible light, it is everything we can receive as information. But light remains the great storyteller, because it has brought us so much of the cosmic record. The horizon also changes over time. As time passes, light from more distant regions can reach us, but accelerated expansion complicates the future. Some regions whose light has not reached us yet may never be able to send light that arrives, because the expansion between us and them grows too quickly. There is a difference between what we can see now, what we might see in the future, and what could ever affect us. This is not an edge in space, it is a limit in causal connection. The universe is not only vast but divided by what can communicate with what. In that sense, horizons are not walls of matter, they are boundaries of possible information. This idea is a little lonely but also clarifying. There may be galaxies that exist beyond our observable universe right now. They may have stars, planets, and perhaps beings who look at their own sky and ask their own version of these questions. But if their light can never reach us, they are beyond our cosmic horizon in a practical sense. They are not unreal. They are not outside the universe. They are outside our possible knowledge, unless some deeper theory connects them indirectly. Science is careful here. It can describe what follows from models, but it cannot claim direct observation when no information can arrive. The horizon is a boundary not only of sight, but of humility. And yet, within our observable universe, We have an astonishing amount to work with. We can map galaxies across enormous volumes. We can measure their redshifts, which tell us how much their light has been stretched. We can study the distribution of matter and compare it to the patterns in the ancient microwave glow. We can watch supernovae in distant galaxies and use them to trace the history of expansion. We can measure how galaxies cluster, how light bends around massive structures, how gas fills the spaces between galaxies, and how the cosmic web has grown. From our small location, using signals that arrive at one planet, we reconstruct the history of a vast visible cosmos. It is a bit like hearing a few notes through a wall and gradually writing down the symphony, except the wall is expanding and the orchestra began playing before Earth existed. The observable universe can therefore look centered without being the whole universe. This is the point to keep returning to gently, because it untangles so many confusions. The galaxies we observe surround us. The ancient glow surrounds us. The horizon surrounds us. But this is what any observer would experience from their own location. We are central to our view, not to reality. The difference is as important as it is easy to miss. A person standing in a field is central to their horizon. A ship at sea is central to its visible circle of ocean. A listener in a dark room is central to the sounds they hear. None of these facts make the person, ship, or listener the center of the whole world. There is even a kind of beauty in being decentered in this way. We are not demoted to insignificance. We are placed in relation. The universe does not revolve around us, but it reaches us. Ancient photons, born before stars like the sun existed, arrive in our instruments. Light from distant galaxies crosses expanding space and ends its journey in a detector, in a data file, in a human mind trying to understand. The observable universe is not a cage. It is a conversation limited by distance and time. We listen to what can reach us, and from those messages we infer a larger reality beyond the edge of our sight. So when we speak of galaxies, horizons, and the observable universe, we're really speaking about the difference between existence and visibility. Galaxies beyond our horizon may exist, but they are not visible to us. The universe may extend far beyond our observable patch, but we cannot simply look and check. Our horizon is not a physical edge where space stops. It is the present limit of information. It is shaped by the age of the universe, the speed of light, and the expansion of space. It gives every observer a centered view, while denying every observer a universal throne. It lets us see deeply, but not completely. And beyond that horizon lies the next question, the one that naturally waits in the dark. If the observable universe is only what we can see, what might lie beyond it? More of the same cosmic web, continuing without end. A finite but unbounded space curving back in ways too large for us to detect. Regions forever beyond contact, following the same physical laws or perhaps shaped by conditions we can only infer with caution. The centerless universe does not end at the edge of our view. Our view ends, and the mind very gently wants to keep going. Our view ends, and the mind very gently wants to keep going. That is one of the most human things about cosmology. We build instruments to gather the light that can reach us. We map galaxies as far as our telescopes allow. We study the ancient glow that surrounds our observable universe. And then, almost immediately, we ask what lies beyond it. Not because we are dissatisfied with what we can see. What we can see is already almost absurdly grand. It contains hundreds of billions of galaxies, each holding billions or even trillions of stars, spread through a cosmic web so vast that the word large begins to feel a bit underdressed for the occasion. But still, at the boundary of visibility, curiosity leans forward and whispers, yes, but what is past that? The first thing to say is perhaps the most important. Beyond the observable universe does not mean beyond the universe. It means beyond the region from which light has had time to reach us. That is a difference worth holding carefully, like a mug of tea carried through a dark room. If something lies beyond our cosmic horizon, it is not necessarily outside reality, outside space, or beyond nature. It is simply beyond our present ability to receive information. The observable universe is centered on us because it is our view. Its boundary is not a physical wall. It is not a shell of glass. It is not a cosmic fence with a small gate and a tired-looking guard asking for identification. It is a horizon, and horizons belong to observers. Think again of the ocean horizon. When a ship passes beyond it, the ship has not vanished from Earth. It has moved beyond what you can see from where you stand. Someone on that ship has their own horizon, centered on them. They may still see other things you cannot. The cosmic horizon is stranger, because it is shaped by the finite speed of light, the age of the universe, and the expansion of space, but the same lesson remains. A horizon is a limit of view, not always a limit of existence. So when we ask what lies beyond what we can see, we're asking about regions of the universe that may be real but are not directly observable from our location, at least not now, and perhaps not ever. The simplest possibility is also the most modest. Beyond our observable universe, there may be more universe much like the universe we can see. More galaxies, more clusters, more voids, more filaments of the cosmic web, all continuing beyond the edge of our vision. If the universe is broadly the same on large scales here, then it may remain broadly the same beyond our horizon. This is not a wild guess pulled from a hat, though hats do have a long and honourable history in human guessing. It follows from the idea that our location is not special. If we're not at the centre, and if the universe looks broadly uniform in all directions across the regions we can observe, then it is reasonable to think the same kind of structure continues beyond what we can see. Reasonable, yes. Directly proven, no. That is the delicate balance. Science can extend patterns beyond direct observation, but it must do so honestly. We observe a large region. We see that on very large scales, it appears statistically similar in all directions. We build models that describe this. Those models often imply that the universe continues beyond our observable patch. But the regions beyond the horizon do not send us light, so we cannot photograph them, map their galaxies, or check whether some distant civilization has finally solved the problem of tangled headphones. We infer. We do not directly see. That distinction matters because cosmology often stands at the edge between measured knowledge and careful extrapolation. It is not less scientific for admitting where the light runs out. It is more scientific. One possibility is that the universe is infinite. That word is easy to say and very difficult to feel. Infinite space would mean that beyond our observable universe, there is not an edge, not a final galaxy, not a last dark stretch, but more and more space without end. In such a universe, our observable region would be only a finite patch of an endless whole. No matter how far you travelled, if travel across such distances were possible, there would always be farther to go. There would be no centre because in an infinite universe, every point is equally surrounded by more space. There would be no edge because an edge would imply a boundary, and infinity is not the sort of thing that politely provides one. An infinite universe can still expand. That sounds odd at first. How can something already infinite get bigger? But expansion does not have to mean adding more space at the outside. It can mean increasing the distances between far separated points. An infinite number line can be stretched so that the spacing between marked points grows, while the line remains infinite. The total extent was never a finite object needing extra room. In a similar way, if the universe is infinite, it may have always been infinite, but denser in the past because distances between regions were smaller. The word smaller here refers to scale, not to the universe being a little ball in a larger room. Again, the room is the trap. The universe is not sitting inside a larger room, at least not in the ordinary picture. The infinite possibility is elegant in some ways because it naturally avoids a centre and an edge. But it comes with its own strange consequences. If space is truly infinite and matter is distributed in broadly similar ways across it, then there may be regions unimaginably far away where arrangements of matter repeat. Not because the universe is copying itself deliberately, like a student trying to finish homework before breakfast, but because in an infinite space with finite possible arrangements in a given region, repetitions may occur. This idea is speculative and depends on assumptions, and it should be handled gently. It is not something we can observe, but it hints at how unsettling infinity can be. An infinite universe does not merely mean more galaxies, it may mean more possibilities than our minds are comfortable stacking neatly on a shelf. Another possibility is that the universe is finite but unbounded. This is a phrase that sounds as if it came from a committee of mathematicians trying to make ordinary people blink slowly. But the idea can be approached through the surface of Earth. Earth has a finite surface area. You can measure it. You can travel around it. Yet if you walk in one direction, ignoring oceans, mountains, borders, and common sense, you will not reach an edge where the surface stops. You may eventually return to where you began. The surface is finite but has no boundary. Now, the universe is not the surface of Earth, and our space has more dimensions than a surface. But the comparison helps. Space itself could, in principle, have a shape that is finite without having an edge. In such a universe, if you travelled far enough in one direction, perhaps you could return to your starting point, not because you turned around, but because space itself wraps around in some higher dimensional way. That is an extraordinary possibility, and scientists have looked for signs of it. One idea is that if the universe was small enough and wrapped around, we might see repeated patterns in the sky, like seeing the same distant region from different directions. So far, observations have not shown clear evidence that our observable universe wraps around in a detectable way. If the universe is finite and unbounded, it is likely much larger than what we can see, or shaped in a way that does not reveal itself easily within our horizon. A finite unbounded universe would also have no centre in the ordinary sense. The surface of Earth has no special centre on the surface itself. You can choose coordinates, you can draw maps, you can declare one location to be the starting point for longitude because sailors and map makers needed a standard. But the surface does not naturally point to one place and say, here is the middle of everything. Likewise, a finite unbounded universe could contain no central location within space. Every observer would still have their own horizon. Every observer would still see outward from their own position. The absence of an edge does not require infinity. It requires a kind of geometry our everyday experience does not easily visualize, which is why cosmology sometimes feels like trying to fold a bedsheet in 4 dimensions while half asleep. There is also the question of whether the universe beyond our view follows the same laws of physics. In the simplest and most widely used models, yes. The same basic laws apply everywhere. The same kinds of particles, forces, and large-scale behavior continue beyond our horizon. This is the conservative assumption, and it has served science well. We do not observe the laws changing with direction in the universe we can see. The ancient light, the distribution of galaxies, and the behavior of matter all point to a universe governed by consistent rules across our observable patch. Extending that consistency beyond the horizon is natural, though again not directly testable in the ordinary sense. But some speculative ideas suggest a larger reality in which regions beyond our observable universe might have different conditions. This is where the word multiverse often enters, wearing a dramatic cloak and attracting both serious physicists and people who would like to know whether there is a version of themselves who remember to water the plants. In some theories related to cosmic inflation, the very early universe may have undergone an extremely rapid expansion, and different regions could have developed into separate vast domains, sometimes called bubble universes. These regions might be far beyond any possible observation, and could, in some versions, have different physical properties. This is highly speculative. It is not the same kind of established evidence as the expansion of the universe or the cosmic microwave background. It is an idea that arises from attempts to understand the earliest moments and the large-scale structure of reality. Cosmic inflation itself was proposed to explain several features of the observable universe, including why it looks so uniform across regions that seem too far apart to have exchanged information in the simplest early picture. Inflation suggests that a tiny early region expanded enormously fast, stretching space and smoothing it out while also magnifying tiny quantum variations that later seeded cosmic structure. Many versions of inflation imply that the universe beyond our observable patch is vastly larger than what we see. Some versions imply that inflation may continue elsewhere, producing many regions like ours. But the details remain uncertain. Inflation is a powerful idea with observational support in broad strokes, but its deeper mechanisms and wider implications are still active areas of research. It is one thing to say the universe likely extends beyond what we can observe. It is another to say exactly what lies there. So the honest answer to what lies beyond what we can see is layered. Most likely, beyond our observable universe there is more space, probably containing more matter, arranged in large-scale patterns similar to those we observe, at least for some enormous distance. The universe may be infinite, continuing without end, or it may be finite, but so large and curved in such a way that no edge appears within our view. It may be part of an even larger structure described by speculative theories. We do not know the full answer. The horizon limits direct evidence. This is not a failure. It is the condition of being inside the universe and receiving information at the speed light allows. There is something deeply important about that limitation. It means cosmology is not simply a matter of building a bigger telescope until everything becomes visible. Bigger telescopes help enormously. They reveal fainter galaxies, earlier stars, more delicate patterns, and more precise details. But the cosmic horizon is not merely a technological inconvenience. It is not like a blurry window that a better lens will fully clear. Some limits are built into the structure of space, time, and expansion. We can improve our view within the observable universe. We can infer more cleverly. We can use different messengers. But if no information can reach us from beyond a certain region, then direct observation ends there. The universe has a privacy setting, apparently, and it is not taking requests. This may feel frustrating, but it also teaches a kind of scientific maturity. Knowing what cannot be known directly is part of knowing. A map with honest borders is better than a map pretending to cover lands it has never seen. When cosmologists describe what may lie beyond the observable universe, they use models grounded in what we can measure. They test those models wherever possible. They look for indirect clues. They ask what different possibilities would imply within our visible patch, but they also accept that some questions may remain beyond direct confirmation, at least for us. That does not make the questions meaningless, it makes them humbling. The observable universe, in this sense, is both enormous and small. Enormous, because it contains more galaxies than anyone can truly picture. Small, because it may be only a tiny fraction of the whole. If the universe is infinite, then the observable universe, vast as it is not just small but infinitely small compared with all that exists. That is the sort of statement that makes the mind quietly put down its tea. Yet it need not be frightening. Scale does not measure significance in any simple way. A sentence can be small compared with a library and still matter. A single note can be brief compared with a symphony and still change the feeling of the music. Earth can be tiny compared with the cosmos and still be the place where oceans move, forests breathe, and minds ask questions about horizons they cannot cross. What lies beyond what we can see may also be beyond the reach of travel, not just sight. Even if we could build spacecraft far beyond anything currently imaginable, the expansion of space imposes limits. Many galaxies we observe today are already so distant that, because of the accelerating expansion, We could never reach them even at the speed of light. Their old light reaches us now because it began its journey long ago when the distances and expansion history were different. But a signal sent from us today towards some of those regions would never arrive. This is a strange asymmetry. We can see some things we can never visit, and there are things that may exist that we can never see. The universe is not only large, it is causally divided, stitched together by what can and cannot exchange information. In the far future, this division becomes even more dramatic. If expansion continues accelerating, distant galaxies will drift beyond visibility. Their light will be stretched, dimmed, and eventually lost to future observers. The night sky of a far future civilization in our merged local galaxy may contain far less evidence of the wider universe. They might see only their own bound island of stars and little hint of the vast cosmic web beyond. They might have to work very hard to discover what we can see more directly now. In a curious way, we live during a fortunate era for cosmology. The universe is old enough for galaxies and planets and observers to exist, but young enough that the wider cosmic expansion is still visible. We have arrived while the clues are still on the table, which is considerate of the cosmos, though I would not rely on it for punctuality in other matters. Beyond what we can see, then, is not just a place. It is a reminder of how observation works. We do not see the universe from outside. We receive signals from inside. Our knowledge is built from light that has crossed space, from patterns in ancient radiation, from galaxies caught at different ages, from measurements made in one small region of a vast whole. The centerless universe is also a horizon-filled universe. There is no middle, but there are limits. There is no edge of all space in sight, but there is an edge to our information. We are neither central nor blind. We are situated. That word situated may be one of the gentlest ways to describe our place. We are somewhere, not the center, not the edge, not nowhere, somewhere. We observe from within the Milky Way in a local group of galaxies inside a vast observable sphere defined by cosmic history. Beyond that sphere, the universe may continue in ways that are ordinary, infinite, curved, or more surprising than our current models can settle. But whatever lies there, it does not restore a center. If the universe continues uniformly, there is no center. If it is infinite, there is no center. If it is finite but unbounded, there may be no center in space. If speculative larger structures exist, our observable region is still not the privileged middle of everything. The old central point does not reappear just because the unknown begins. There is a comfort in that, though it is a quiet one. The universe beyond our vision does not need to be known completely for our knowledge to be meaningful. We can understand the principles that shape what we see. We can recognize why our horizon surrounds us. We can infer that the whole is likely larger than the visible part. We can admit uncertainty without filling it with a false center. The unknown is not an empty slot where old assumptions should be placed back in. It is simply the unknown, patient and wide. Perhaps, then, what lies beyond what we can see is more than a scientific question. It is a lesson in how to live with partial views. Every creature sees from somewhere. Every mind has horizons. We know our own lives from the inside, just as we know the cosmos from one location within it. We mistake our viewpoint for the whole when we are tired, frightened, or too confident. Then learning widens the frame. It shows us that our horizon is real but not final, centered on us but not proof that we are the center. The universe teaches this lesson at the largest possible scale, using galaxies as examples and ancient light as evidence, which is perhaps excessive but effective. And with that, the question begins to soften. What lies beyond what we can see? Very likely more universe. Perhaps infinitely more. Perhaps a finite space curving beyond our detection. Perhaps regions forever beyond contact. Perhaps possibilities our present theories only hint at. We can speak carefully, infer where evidence allows, and remain honest where it does not. But the absence of a complete view does not make our view worthless. It makes it precious. From this small world, inside this one observable sphere, we have learned that the universe does not revolve around us, does not expand from us, and does not require a centre at all. And somehow, instead of making us less connected, that realization places us more deeply inside the same vast story as everything else we can see, and perhaps everything we cannot. And somehow, instead of making us less connected, that realization places us more deeply inside the same vast story as everything else we can see, and perhaps everything we cannot. The universe does not need us to be at its centre in order for us to belong to it. That may be the quietest and most useful lesson in all of this. For a long time, human beings searched for our importance by looking for our position. We asked whether Earth stood at the middle, whether the heavens turned around us, whether the great architecture of reality had been arranged with our world as its fixed point. It made sense to ask that. We begin life at the centre of our own experience. We open our eyes and the world arrives around us. Sounds come toward us. Light meets us. Hunger, warmth, fear, comfort, voices, rooms, faces, all of it is first understood from the small, central place of the self. It is natural that when our ancestors looked upward, they first imagined the sky in the same way, a great dome overhead, moving around the still ground beneath their feet. But the universe has taught us, patiently and repeatedly, that central position is not the same as significance. Earth is not the centre of the solar system. The Sun is not the centre of the Milky Way. The Milky Way is not the centre of the universe. And the universe itself, as far as modern cosmology can tell, does not have a centre in the way a table, a room, or a spinning wheel has one. This could sound like a long series of demotions, as if science has spent centuries walking into the human imagination and gently removing the nicer furniture. First the central Earth goes, then the central Sun, then the central galaxy. Finally, even the idea of a cosmic centre is taken off the shelf and placed in the cupboard marked not useful at this scale. But that is only one way to tell the story, and perhaps not the best one. Another way to tell it is that every loss of centrality opened a larger home. When Earth moved from the centre, we gained the solar system as a real place, with other worlds moving by the same laws. When the Sun became one star among many, we gained the Milky Way, a vast galaxy filled with suns, nebulae, dust lanes, and long histories of star formation. When the Milky Way became one galaxy among many, we gained a universe rich with structure, deep time, and more galaxies than human intuition can comfortably hold. When the universe lost its centre, we gained a deeper understanding of space itself. We did not fall out of meaning. The map expanded. The old middle was too small for what reality turned out to be. There is something deeply calming about that, if we let it settle. You do not have to be at the centre of everything to be part of everything. A leaf is not at the centre of the forest, but it belongs to the forest. A wave is not at the centre of the ocean, but it belongs to the ocean. A single note is not the centre of a symphony, but the music would not be quite the same without it. Earth is not the middle of the universe, but it is made from the universe. Its rocks, oceans, air and living cells come from the same cosmic history as the galaxies we study through telescopes. The atoms in our bodies were formed through processes that began in the early universe and continued inside generations of stars. We are not spectators outside the cosmos, peering in through the glass. We are one of the ways the cosmos has become able to look back at itself. That phrase can sound grand, and perhaps a little too pleased with itself, so let us say it plainly. We are physical beings made of matter that has a cosmic history. The hydrogen in the universe began in the early hot stages after the Big Bang. Heavier elements were forged in stars and in violent stellar events. Carbon, oxygen, iron, calcium, and many of the ingredients of planets and bodies were made by earlier generations of stars before being scattered into space and gathered again into new systems. Our solar system formed from such enriched material. Earth formed from it. Life eventually arose from chemistry on this planet. Human beings with brains shaped by evolution learned to measure light, build instruments, and infer the history of space. That is not centrality in the old geometric sense. It is continuity. We are inside the process we are trying to understand. This is why a centerless cosmos is not an empty cosmos. It is not a universe without structure, without order, or without any place for us. It is a universe in which place is relational. Every location is defined by its relationships to other locations, by distances, motions, histories, and horizons. We are here, in the Milky Way, in a local group of galaxies, within the observable universe that surrounds us, because light has had time to reach us from those directions. Another observer elsewhere would have their own here, their own local structures, their own observable horizon. No one needs to occupy a universal throne. The universe allows many viewpoints without granting any one of them the title of absolute middle. It is less like a palace with a central chamber, and more like a vast landscape where every traveller has a different horizon. This also changes how we think about being small. People often say that astronomy makes them feel insignificant, and it can. The distances are enormous. The timescales are almost impossible to imagine. Our entire written history is a brief flicker compared with the age of the stars. A human life is very short beside the lifetime of a galaxy. Earth is a tiny planet around an ordinary star in one galaxy among many. If significance were measured only by size or duration, then yes, we would be in trouble. A teacup would outrank a thought if volume were all that mattered, and that seems like a poor system, even for a teacup. But size is not the only measure of meaning. A brain is small compared with a mountain, but it can understand the mountain. A book is small compared with a building, but it can change a life. A telescope mirror is small compared with the galaxy it studies, but it can gather ancient light and reveal patterns across billions of years. The fact that we are physically small does not make our perspective worthless. It makes it remarkable that any perspective exists at all. In a universe without a centre, meaning is not handed down by location. It is made through relation, understanding, experience, and care. We do not matter because space has placed us at the middle. We matter because we can ask where we are, learn the answer, and still feel wonder rather than despair. There is a kind of emotional adjustment required here. The old central universe was comforting because it seemed to give us a fixed place. The modern universe is comforting in a different way. It does not say you are the centre. It says you are included. It says the same laws that shape distant galaxies also shape the matter around you. It says the light from the early universe reaches us from all directions, not because we are privileged, but because we are part of a shared cosmic history. It says every observer has a horizon, every place has a view, every location is somewhere inside the unfolding whole. That is not a cold answer. It is a wider one. Of course, there are still many things we do not know. We do not know the full size of the universe. We do not know whether it is infinite or finite, in a way beyond our current observational reach. We do not know the complete nature of dark matter, even though its gravitational effects are written across galaxies and clusters. We do not fully understand dark energy, the name we give to whatever is driving the accelerated expansion of the universe. We do not have a final tested theory that unites gravity with quantum physics in the earliest moments. We do not know whether regions beyond our observable universe are simply more of the same, or whether deeper theories will reveal a larger structure more surprising than our current models. A centerless universe is not a solved universe. It is a clearer mystery. That matters because science is sometimes misunderstood as removing mystery. In truth, it often replaces a vague mystery with a sharper one. The old question might have been, where is the centre of the universe? The better answer says there is no centre in the way you are imagining. Then new questions appear. What is the full geometry of space? How did the early universe become so uniform? What exactly caused the expansion to accelerate? What happened at the earliest times our theories can approach but not fully describe? What lies beyond our observable horizon, if anything can be meaningfully said about it? Science does not turn the universe into a small, tidy room. It turns the lamp up just enough for us to see that the room is part of a much larger building, and then notices that the building may not have walls in the usual sense. Very helpful. Slightly inconvenient. Exactly the sort of thing the universe would do. The absence of a centre also teaches caution with perspective. From Earth, the sky appears to surround us. From our telescopes, the observable universe appears centred on us. From our measurements, distant galaxies recede in every direction. Each of these facts could tempt us back towards central thinking if we forget what observation means. We are always at the centre of what we can observe, because observation arrives where the observer is. That is true in ordinary life as well. Your own experiences arrive from your own viewpoint. Your worries, memories, hopes, and plans can feel like the whole world because they are the world as it reaches you. But other people have their own centres of experience. Other places have their own horizons. The lesson of cosmology has an oddly human echo. Being at the centre of your view does not mean being at the centre of reality. This is a useful lesson to carry gently. It does not ask us to erase ourselves. It asks us to place ourselves accurately. We are not nothing. We are not everything. We are somewhere. Somewhere specific, temporary and extraordinary. We live on a planet with weather, oceans, clouds, forests, cities, deserts, insects, mathematics, music, and people who occasionally stare into the fridge as if the mysteries of existence might be hiding behind the yogurt. We live under a sky that has been studied for thousands of years, first with eyes and stories, then with instruments, measurements and theories. We live at a time when the evidence of cosmic expansion is visible, when the ancient afterglow can be measured, when galaxies can be mapped, when the question of a centre can be answered not by pride or discomfort, but by observation and reasoning. And that answer is wonderfully simple once the old picture has been set aside. The universe does not have a centre, because it is not expanding from one central place into empty space. Space itself is expanding. Every distant, unbound region moves away from every other in the large-scale pattern. Every observer sees themselves at the centre of their observable universe, because their observable universe is defined by the light that has reached them. The Big Bang was not a blast at a location, but an early hot dense state of the universe, a state from which all the regions we can observe have evolved. The horizon around us is not an edge of everything, but the limit of what can be seen from here. The universe may continue beyond that horizon, perhaps far beyond it, without ever needing a central point. It is easy to say this now, but the idea is the result of a long human effort. Generations of sky watchers, mathematicians, telescope builders, physicists, and astronomers each moved the picture a little closer to reality. Some measured planetary motions, some studied light, some built models of gravity and space, some mapped galaxies, some detected the faint ancient glow that fills the sky. Each contribution helped loosen the grip of the old centre, not all at once, not without resistance, but steadily. There is something gentle in that too. Our understanding expanded in a way that almost mirrors the universe itself, not from one perfect insight, but from many points of curiosity growing apart and connecting into a larger structure. So where does that leave us tonight, as the mind grows quieter and the scale of everything becomes both clearer and softer? It leaves us in a universe without a central seat, but not without orientation. We can still know where we are. We can say we are on Earth, orbiting the Sun, within the Milky Way, part of the local group, inside the observable universe. We can trace our matter back through stars and the early cosmos. We can place our horizon in the history of expanding space. We can understand why every direction looks deep and why none points to a universal middle. We can be humble without being lost. There is a very practical piece in that. You do not need the universe to revolve around you in order to rest within it. The night does not become less beautiful because the stars are not fixed to a dome around Earth. The sun does not become less warming because it is one star among many. The Milky Way does not become less magnificent because there are other galaxies beyond it. And you do not become less real because the cosmos has no center. In fact, the opposite may be true. A centerless universe gives every place its own view, every observer their own horizon, every life its own small circle of experience within the wider dark. It does not reduce belonging, it spreads it out. Perhaps that is the best place to let the thought rest. The universe is not arranged around us, but we are arranged from it. The same expansion that carries distant galaxies beyond reach also made space for galaxies to form. The same early variations that made the cosmos slightly uneven eventually allowed stars and planets to exist. The same ancient light that tells us we are not central also tells us we are connected to the beginning of the observable universe. We're not at the middle of the map, but we are made of the map. We're not the reason galaxies move, but we are able to understand something about their motion. We are not the center of the cosmic story, but we are a part of the story becoming aware that it has no center. And so, dear listener, we have wandered from the old dream of a central Earth to the wide modern picture of expanding space. We have let go of the image of a cosmic explosion bursting from one point. We have watched the balloon and the raisin bread help us and mislead us. We have followed galaxies outward and light backward, met the horizon of the observable universe, and peered as carefully as we can toward what may lie beyond what we can see. The answer we found is not a location, but a change in understanding. The universe does not have a center, because the universe is not the kind of thing that needs one. If you're still awake, I hope the thought feels less dizzying now and more spacious. And if you're drifting, then let it become very simple. There is no cosmic middle you have missed. There is no faraway point where everything truly began while we sit on the outskirts. Wherever you are tonight, in a quiet room, beside a window, under city lights, near fields, near rain, near the low hum of ordinary life, you're inside the universe, not outside its meaning. You're centered in your own experience, surrounded by your own horizon, part of a cosmos that expands everywhere without choosing a middle. If this journey brought you a little calm, a little curiosity, or just a softer way to think about the night sky, I would be ever so grateful if you gave the video a like, subscribed, or shared it with someone who might enjoy a peaceful walk through the strange logic of the universe. And if you would like, leave a comment telling me where you're listening from, and whether thinking about a centerless cosmos makes you feel smaller, calmer, or somehow more at home. For now, let the question loosen. Let the need for a center fade. The universe is wide enough without one, and here, in this small moment within it, there is nothing more you need to find. Sleep well, fellow traveller, wherever your horizon begins tonight.